dirter.
Tradoon.
A dirter.
Blue is cheap.
Tradoon.
Ontogeny.
This is where it really fits.
Tradoon.
Dur.
Location unknown.
Charter 373. This is Commander Mills. My ship was hit by an undocumented asteroid. Send help.
We've crash landed on an uncharted celestial body.
Location unknown.
The atmosphere is breathable.
There's something alien out there.
You need to be quiet and move.
Well, hello, everybody, and welcome back to Paleontologizing. A happy Monday to all of you. I hope your week is starting off well, particularly if you're watching live. It might be a different time for you if you're watching this on the VOD or on YouTube, but I'm glad you're here. Welcome. I was determined to start on time today, and I managed to do that. Except there's still... Shoot, where's my necklace? Let me be right back. Hang on a second here. And then I'll introduce all the new folks to the channel. Hang on just a minute. There we go. Excellent. Well, everybody, welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. So, talking about science, talking about my own scientific work on fossils. Hopefully, most of you already know that a paleontologist is a scientist who studies fossils. I work on dinosaur fossils in particular, hence dinosaur paleontologist. Dinosaurs are what I study, what I publish on in scientific papers, in the scientific literature. Dinosaurs are what I dig up during the summers. And Sweetie Pie misses me a lot while I'm out there digging up dinosaurs all summer long. Hello, Sweetie Pie. How are you doing? You having a good day so far? Yeah. My whole point of being here on Twitch is to do science outreach, to talk to folks about natural history, about the origins of biodiversity, about why it's important to understand the history of life on Earth. What do you think, Sweetie Pie? We've got a brand new cat cam today, by the way. Same overlay, but new camera. We'll be talking about that in a minute. But yeah, Sweetie Pie, how are you doing? It's good to see you. Yeah, what do you think? What do you think of the new camera? Do you like it? Do you approve? Is that up to your standards? Anyway. Fossil science is what I do. That's what I do here on Twitch. We'll talk about new scientific discoveries, particularly today. Thank you, Dino Soar, for the follow. Sounds like you're in the right place. Welcome. We're going to be talking about some new publications just came out. So what's new and hot in the world of vertebrate paleontology? And any questions that you good folks might happen to have. Any questions at all about natural history, about the fossil record, about extinction or evolution or any of that good stuff. Don't be shy with those questions. I'm here to answer them for you to the best of my ability. This is how I do science outreach. So, I'm glad you could be here. Thank you. And Dinosaur, I dig those emotes. It's good to have you here. Yeah. Sweetie Pie, I think you want some treats. Is that what you want? Yeah. Is that what you want, sweetie? I think we can make that happen for you. I think we can make that happen for you. Yeah. Here, give me just a second here. We have got some brand new cat treats, which just arrived, thanks to the very generous Claire Burr. So let's go ahead and get some of those, these special dental treats that the cats love. Yeah. Take a look, sweetie pie. Ho, 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 ho. Yeah, look, brand new bag. Brand new bag. How exciting is that? Yeah. Right. Open it for you. Ooh. Oh, that's not to eat. That's just part of the packaging. Check that out. Yeah. Oh, ho, ho, ho. Oh, good stuff. Here. Have a few. What do you think? Is that pretty good? Yeah. Excellent. Eddie Scarin says, what dinosaur group had smaller arms than T-Rex? Eddie Scarin, I can do even better than that. I can tell you a dinosaur group with no arms. Is it the giant moas? Is it moas or elephant birds? But one of them has got no arms at all anymore.
Dinosaurs hold a special
Thank you,
for children.
Dyson Dinosaur.
Hello,
I really appreciate.
Between a new mind-blowing manuscript and 3D printing madness, here to support.
Thank you, Dyson Dinosaur. Holy cow, thank you for your continued support. 18 months is a long time, and we both really appreciate it, me and Sweetie Pie, and the rest of this community too. If any of you are not yet following Dyson Dinosaur, you are missing out. He streams in Italian most days. He's from Italy, but he's a dinosaur paleontologist on weekends. Like, I believe it was this past Sunday, yesterday, he did a stream about dinosaur paleontology in English here on Twitch. Let me see if I can find that VOD here. There we go. Yeah, good stuff. Dinosaur Sunday. Here we are. Oh, talking about these expeditions to Niger. So Felipe was actually part of some of these expeditions. Yeah. Good stuff. Anyway, give him a follow if you're not already doing so.
One of the major threats in the air were, bandits and terrorists.
I've never had to deal with bandits in the field. Holy cow.
Killing at least 100 people.
We saw a video where I was in a pic. Oh, very cool, Dyson Dinosaur. Very, very cool.
The number of Nigerians who died in the violence more than doubled from 2018 to 20.
Anyway, yeah, go follow Dyson Dinosaur. Let's get another shout out for Dyson Dinosaur. There we go. But, Moa without arms. Thank you, Claire Burr. Yeah, Moa have got no arms. Moa got Noah arms. I saw Lenina posted that earlier, right? Yeah. But yeah, if we're looking for a dinosaur group with smaller arms than Tyrannosaurs, the Moas, I think as a group, they may be the only theropods that have ever completely lost their forelimbs altogether. Just not even a single remnant of them. No arms at all. And these are Oh, they're these gigantic birds. We had this, this picture with Richard Owen, coiner of the word dinosaur in 1842. This was on our wall on Thursday. It's part of our backdrop. But yeah, these were giant flightless birds that were driven to extinction by humans. Very recently, like within the last, less than 100,000 years ago. Probably much more recently than that. But they were some of the largest birds that ever lived. Very, very cool critters. There's a lovely illustration by Gabriele Guetta there. Just beautiful. Such cool animals, and no arms at all. Yeah. Pandaria says, it's Big Bird. It's even more specialized than Big Bird because these guys have lost their arms. Big Bird famously has got arms, or at least one functional arm. The other one is vestigial. But yeah. Yeah. Could that be, some urban gigantism exhibited by Big Bird? And we have island gigantism here in Moas. Yeah, pretty neat. Anywho, on today's broadcast, we're going to be catching up on some fossil news. There's a bunch of new publications that have come out, many of which I'm excited to talk about. And then we've got some other news that I'm sure people will be trickling in and asking about too, that I'm not as excited about. We've got this whole brouhaha with this Stegosaurus that went up for auction during the summer. And it's just gone up on display at the American Museum of Natural History, so we'll get to that when we get to it. But I'm guessing at least 2 or 3 people are going to trickle into chat and ask me if I've heard about it. And, yeah, rather than covering that first, we'll wait a little while. Let's do some happier news first. Wombat Hole says, how much of that body is air sac? Oh, for me, not very much. Mammals don't really have air sacs, Wombat Hole. Neither humans nor marsupials like wombats. If you're talking about the moa, a decent part of the body would be air sac. These guys would be lighter weight than you would imagine. But at the same time, since these guys had been flightless for a good while, I think they'd been flightless for like tens of millions of years. They're no longer optimized for super, super lightweight in the way that volant birds are. Oh yeah. Hominins are water sacs. There you go, Squiggles. Yeah, to a certain extent, yeah. Anyway. Crimson Carnotaurus says, and with the moa gone, another bird lost out. The host eagle who preyed on them. Yeah. Yeah, one of the largest predatory birds that's ever existed. These guys were enormous, and they preyed upon moas. Yeah. It was a dinosaur-eat-dinosaur world in ancient New Zealand. Until people arrived and messed it all up. Yeah. These are some pretty large birds. Yeah. Interesting. Not as large as I assumed they were. I don't know a great deal about these guys. They're a little bit smaller than I would expect. Huh. Yeah, anyway. Good stuff. Yeah. And are they at all related to harpy eagles? Presumably they're both acipterids. So presumably they're both on the same branch over here. There we go. Acipteriformes. Yeah, here we go. Hawks and eagles, the Acipteriformes. And it seems they became a group about 77 million years ago. They diverged from their ancestors then. So, yeah, I would say the Haas eagle is certainly an acipter form. There we go. And it is the largest known eagle to have existed, with an estimated weight of 10 to 18 kilos, 22 to 40 pounds, compared to the next largest extant harpy eagle, at up to 20 pounds, 9 kilos. Anywho, there we go. So up above, really big, is a right hind foot of a Haas eagle, and then the, what is it called? Little eagle, I think, is its closest living relative. Right there, you can see the size difference. So yeah, and harpy is only half the size. I don't know, it's probably more than half the size. This is not a harpy eagle, this is a little eagle right here, if memory serves. Yeah, little eagle. A very small eagle endemic to Australia. So a harpy eagle is not going to be that much smaller than a Haas eagle. Yeah, harpy eagles get to be pretty large. Yeah. Oh. They're big birds. Yeah, not quite as big as Velia, but still pretty big, you know? Yeah. And they go for monkeys and sloths. They do indeed, Crimson Carnotaurus. Yeah, they can crush a monkey's skull in their claws like that. Just they're pretty big. They're not that much smaller than a Haas eagle would have been. Yeah. But yeah, and wild country. Yeah, we talked about albatrosses a while ago, maybe a couple weeks ago. Albatrosses have the longest wingspan of any bird, but they don't have the most wing area. We talked about how the albatross has got really narrow wings, almost like a U-2 spy plane. It evolved for really, really long distance flight, way out over the ocean, taking advantages of those thermals above the waves. Yeah, anywho. But yeah. Anywho. Oh, let's, before I forget, we're gonna post to Blue Sky, and also I'm gonna show you maybe a couple of pictures from the weekend. It was the annual holiday party, Fossil Fuel Festivus, at the Museum of Paleontology in Berkeley, just down the road, and I did manage, by hook or by crook, to finally get my coelacanth shirt printed for that, which I was very excited about, and I was able to show that to some fish researchers, some colleagues at Berkeley, and they liked it a lot. I was really happy about that. But yeah. And the hat on the fossil display. I know, right, Reiko? Yeah. This is the Wonkel Rex here. From such paleontologizing emotes as this and this. That's the same Tyrannosaurus specimen there. Yeah, the Santa hat's a nice touch. It really is. But yeah, check out the shirt. I was able to finish this just before going to the party, and only managed to set off the smoke alarms in the house one time when I was curing it. Check it out. This is a design that I did last year, and I was trying to get it printed, and it didn't work. I had a bad batch of photo emulsion. So, pretty happy with how it turned out. I printed 3 different copies of it. Was able to get the screen burned last minute using sunlight rather than using a photo flood bulb. So I was pretty happy about that. But yeah, we will be celebrating Fishmas on Fishmas Day this year, December 23rd. For those of you who are wondering what the heck are we talking about, Fishmas, I will explain presently. Fishmas Day, celebrating the discovery of the coelacanth on this day in 1938. Fire alarm sounds exciting and festive. Yeah. Oh boy. There we go. Yeah.
Life began on the Earth about 600 million years ago, and now...
No, it didn't. It was well over a billion years ago. Oh, hello, Mini Pie. How are you doing? Oh, Mini Pie's like, I believe, excuse me, I think I smell some treats. I think you do, Mini Pie. You're just gonna walk all over everything, aren't you? Yeah. How you doing? How you doing, Minnie? Yeah, this is cat number 2 today. 2 of 3. Mini Pie, how are you? Yeah, I heard there would be fish. Yeah, well, the point of the coelacanth is that we're all fish, Mini Pie. We'll be talking about that on the 23rd for Fishmas Day. But and you're just gonna get hair all over my new shirt, huh? Yeah. Get hair all over my new shirt. Well, let's get you some treats. Would you like that? Would you like that? It's her shirt now, says Franco. We'll see. We'll see, Mini Pie. You might be my landlord, but you're not gonna take my shirts. Oh, what's this over here? Oh my goodness. My stars, what is this? Brand new treats, courtesy of Claire Burr. Look. Oh yeah. There we go. Look at all of those. My goodness. Yeah. You better chew them up. Don't swallow them whole. They're dental treats. They're supposed to be good for your teeth. You're supposed to crunch them. You're supposed to crunch them. Don't swallow them whole. Uh-oh, and here comes Sweetie Pie again. Hi, Sweetie Pie. We've got cats galore here. Chew them up. You gotta chew them up, Mini Pie. There you go. More than one crunch, please. Just gonna lick that one and leave it there? What's going on with you? Don't get distracted. Sweetie Pie's not gonna steal your treats if you eat them. She will get them if you don't eat them. You're just gonna leave these here? Just gonna leave them here. Oh boy. Don't drink my water. It's not for you. Well, okay. Now I've got 4 saliva-coated cat treats on my desk, along with a pool of cat spit. Gross. Gross, Mini Pie. Anyway. What were we talking about here? Oh yeah, the coelacanth, and why it's important. Check out this old newsreel. The prehistoric fish.
Life began on the Earth about 600 million years ago.
Probably about 3 billion years ago, but yeah.
Arrived back in South Africa with one of its earliest inhabitants. A fish called the coelacanth. It was caught by a native fisherman near Madagascar.
This is the second one
Professor
ever
unpacked
found.
his antique treasure before South Africa's Prime Minister, Dr. Malan, who had placed a plane at his disposal to collect the fish before decomposition set in. The coelacanth, thought to have become extinct about 50 million years ago, is described as a fish with arms and may prove to be the link between man and his sea ancestors. If so, we were once a pretty kettle of fish.
Good stuff. Yeah. We will be talking about these guys.
In the late 1930s was quite an astounding finding. These fish were believed to have lived in the time of dinosaurs and gone extinct along with them, as evidenced by a lack of coelacanth fossils dating past about 65 million years ago. Their general lack of changes from their ancestors have given rise to the coelacanth's nickname, the living fossil. Though we all know that nickname isn't exclusive to them. Previously, there were thought to be somewhere around 100 coelacanth species, though today there are only 2, and they're both
that we know of.
Extinction. Coelacanths live in ocean waters, typically staying between 220 to 2,300 feet deep. They spend the daytime hiding out in rocky caves, with which their speckled bodies blend in perfectly. Coelacanths come in either blue or brown with white spots. And
There's 2 species that are known today. Latimeria chelumnae, which is found off of the southeast coast of Africa, kind of between Madagascar and mainland Africa. And then we've got the Indonesian coelacanth, which is Latimeria manatoensis, I think? Yeah, manatoensis. These are kind of a browner color, and they were discovered in the 90s in Indonesia. There might be other species of coelacanth as yet undiscovered in other parts of the world too. We'll talk about that a little bit on Fisherman's Day. They are such cool fish. They're one of my favorite critters. Got a coelacanth right here, so that's why. And you know, as paleontologists, we all adore coelacanths because they're one of these critters that were previously only known from the fossil record, assumed to be extinct, and then they were discovered alive. To the surprise of everybody. Pretty cool. So yeah. Merry Fishmas indeed. We'll be celebrating that on the 23rd. But yeah. And Death of Barney says, Vancouver Aquarium used to have a preserved one, but they pulled it from display as it was deteriorating too much. That's happened in a lot of places. I know the Los Angeles County Museum used to have one also. And I think that might be... I think that also might now be... There we go. Yep, there's a picture of it. I've seen it in person. Not a megamouth shark. That caption is incorrect. But, yeah. Anyway, they may have also pulled theirs off of display. I'm not totally sure. And they've got a model of one right there. Anyway, are they the oldest existing species? Asked Digital Deck. No. I mean, it depends what you mean by oldest existing species. There kind of isn't an oldest existing species. Because over time, species change. That's a constant. Nothing stays the same. If it were, it would be extinct, you know? If it had stayed the same. All living things change over time. That's evolution. You can't stop it. If you stop evolution, that's because you've driven something into extinction, you know? So none of the species that are around today are the same that they were 100 million years ago, 1 billion years ago, 3 billion years ago. None of them are the same. Does that make sense? Yeah. That would seem difficult to measure. There you go, Otterdo. Exactly. Yeah. And there you go. Sloppy Salamander says oldest extant species. How much time is enough of a gap to call something new if the morphology is very similar? Excellent question, Salamander. Excellent question. And we don't have a definite answer to that. Like many things in nature, it's kind of subjective. It's kind of loosey-goosey. There's gray areas and gradients there, you know? So yeah. Yeah. And Casey Snorrit says, I've given up on trying to understand when we decide something is a new species. It's really difficult to do in the moment, you know? As a lineage of living things splits, in the case of cladogenesis, where you get populations that split and they're on their way to becoming new species, how different do they have to be in order for you to call them new species? Because sometimes they can come back around and hybridize, and that's probably more common than we realize. And yeah, so it's tricky like that. Or in the case of anagenesis, here, let me show you. Anagenesis versus cladogenesis. So, here we go, this'll work. And we've even got sauropod dinosaurs as an example here. Cladogenesis is when you've got the genesis of new clades, new evolutionary groups. So you get speciation with splitting. This is the wrong word. It's not specification, it's speciation. So that's wrong. Maybe they had autocorrect ruin it or something. But speciation is when you've got new species being formed by a split. That's cladogenesis. So how long do these two new lineages, how long do they have to be separate before you call them new species? Because if it's only been a little bit of time and there's only been a few mutations, they could still interbreed. It's a wishy-washy, kind of subjective question, you know? It's even more wishy-washy when we get to anagenesis, where that's just one lineage without splitting. Just one lineage slowly changing over time. Like, this is a population where everybody's exchanging genes. You don't have splits due to reproductive isolation. At what point do you say that this guy is a different species from this guy, or this guy, or this guy? It becomes really subjective, you know? Especially since they're separated by time. You know, these are like multiple generations through here. You can't say, well, you know, we'll test if they're different species because, you know, they're different species if they can't interbreed anymore. Well, shoot, none of these guys can interbreed because they live at different times. You can't run that experiment. You can't see if they can interbreed, you know? So, yeah. Yeah. So, when something actually becomes a new species is one of those really tricky questions. It's not cut and dry. And I feel like that's... I've even spoken with other scientists in other fields, and they're, like, really frustrated by this idea. They're like, well, it can't be. You have to be able to draw a line somewhere. I've talked to, like, physicists about this kind of thing. Like, no, nature doesn't work that way sometimes. Sometimes, it's just kind of loosey-goosey. It's a little bit subjective. When we try and take nature and stuff it into these neat, tidy little boxes, you know, that are more comfortable for our human brains to comprehend, sometimes we're doing nature a disservice there. Sometimes we're discounting the amazing complexity of nature, you know? So yeah. 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 I hope that makes sense. DM Wing says it's exceptionally difficult to get fossils to mate in captivity. I would agree. Yeah. And Shark Geek, excellent example, says, so sand tiger sharks in the US, some of you in chat are probably familiar with these. They're really popular aquarium sharks. They're also called, what is it? Ragged tooth sharks, I think, is another common name for them. But they're really popular in aquaria because they look really formidable, but they're actually pretty docile. And they do really well in captivity. They only rarely eat other sharks in captivity. But yeah, these guys. Shark Geek says, sand tiger sharks in the US and other populations in Australia are genetically different despite looking identical. I've heard both arguments for and against them being different species. So even in animals today that we can examine in the laboratory, or even try to interbreed them, like run experiments on, even there, it gets, you have controversy over this. There's uncertainty about whether these critters should be considered the same species or different species. These populations off the southeast coast of the US, and like Georgia, that area, Gulf of Mexico, and then the ones down by Australia. Are they the same species or are they not? They clearly came from the same ancestor very recently. Or fairly recently, we think. But, like, have they been separate long enough to be considered different species? We don't know. Yeah. But yeah. And they're not convergent, Crimson Carnotaurus. We do know that they come from the same ancestor. So we'll look them up on our Tree of Life here. We'll go from hawks, where we were, to sand tiger shark. They're not related to tiger sharks, if I recall correctly. Again, this is why we use scientific names when we're talking about this thing. Bumpy tail, raggedy tail. I don't think that's it. Shoot, what are they? Sand tiger shark. What's their Latin binomial? Sand tiger shark. Here we go. Carcharias taurus. There's that bull name there, like, Eddie Scarron says in Italian they're called bull shark, which is interesting, because in English, bull shark is a very different shark. There we go. Carcharias taurus. Sand tiger shark. There we go. They're critically endangered? You're kidding me. I thought they were really common. Huh. What were we looking at? Yeah, Anyway, it's pretty certain that the ones in Australia and the ones off the coast of the US are not... It's not convergent evolution. They share a common ancestor. That's why they're so incredibly similar. And very well might be the same species. I think they're currently considered... I think it's the default assumption is that they are the same species. So, yeah. In Italian, they call them pescetauro. Oh, interesting. Bullfish? Interesting, Sharky. Some places they are fished near extinction. That is distressing. Sharks are such misunderstood creatures. They are so persecuted. Oh, man. We'll do a shark stream one of these days, and we'll talk more about shark conservation. But yeah. Yeah. And Duster says, is this the same argument as T. Imperator, T. Regina, and T. Rex? With that, it's a little bit different because those are also separated by millions of years. Whereas the Australian and North American Carcharias taurus, sand tiger shark, they all exist at the same time. But when we're looking at 2 or maybe 3 million years of Tyrannosaurus evolution, when you've got just a few data points, just a few skeletons, separated sometimes by millions of years, you could be looking at evolution between those. And that could be a source of variation between Tyrannosaurus rex, Tyrannosaurus regina, and Tyrannosaurus imperator. We don't have a good enough handle on all that yet to really know what the source of variation is. It could also be sexual dimorphism, potentially. I don't suspect it is, but it could be that the males and females look different from one another. It could very well be a lot of ontogenetic variation too. The differences between different life stages. We know that Tyrannosaurus, when it grew, it changed a tremendous amount from baby to adult, it looks like entirely different kinds of dinosaur at different growth stages. We know that Tyrannosaurus goes through an enormous growth spurt from here to here. And it's also probably doing different ecological jobs. It's, for some intents and purposes, it's a different animal, you know? Living in a different part of the environment, probably feeding on different prey, different lifestyle, different appearance. So yeah, dinosaurs are really interesting like this. Looking at how they develop like that. Yeah. Anywho. Eddie Scarin says Nanotyrannus is just a juvenile T-Rex. That's something that we'll probably be talking about a lot more over the next few months, because I suspect there's going to be a new paper coming out. But yeah, ontogenetic niche partitioning. There you go, Golganik. Yeah. Yeah. There's this specimen here. The Cleveland skull. So called because it now resides in Cleveland, Ohio. It's originally from Carter County, Montana. But this Tyrannosaurus, or possibly Nanotyrannus skull, is, it's controversial. Here.
Ontogeny.
Here's a clip. Not Centrosaurus, but here.
The more we learn about them, the more we need to ask. Perhaps the most controversial question of all concerns their fate. In 1987, Robert Bacher was on a routine visit to the Cleveland Museum of Natural History when he made an intriguing discovery.
There are two places to hunt for dinosaurs. You can get yourself a Jeep and go to the Badlands of Montana and dig holes.
Better yet, a Toyota.
You can find new kinds of dinosaurs. Then there's the other place. Go to a basement like this, a gloomy place, where museums keep their research collections in careful storage, specimens collected 20, 30 years ago, waiting for the scholar to come by and read the bones. And these new discoveries of dinosaurs in basements and in the Badlands are challenging everything we thought was true about dinosaurs. These new discoveries are saying we've got to rethink the ideas that dinosaurs were cold-blooded, rethink the idea that they were stupid and slow, and rethink the idea that they died without descendants. And guaranteed, in museums like this, there'll be every year new discoveries about dinosaurs.
This is true. Like, work in the collections is important. But nothing beats fieldwork. Nothing beats actually discovering new specimens, gathering better data on them. The thing about specimens like this is that they often don't have good data associated with them. They were dug up a long time ago, before our standards of collection were very good. So oftentimes we don't know exactly where and when they are from. With a lot of important fossil specimens, we don't have any more detailed information than, oh, it came from this particular county in the United States. And so if we're trying to figure out exactly when in time they're from, oftentimes we can't do it with specimens like that. And they're almost scientifically worthless in a lot of cases. Anyway, that's why fieldwork is so important, and why sometimes it's really, really important to go out and, you know, try and rediscover these old localities. Hello, Sweetie Pie. You've returned. You're cleaning up the treats that Mini Pie left, huh? Yeah. Aw, Sweetie Pie. Yeah. Look at all those. Sorry that Mini Pie slobbered on them. But I don't think you really mind, huh, Sweetie Pie? No. Anyway, before we get too sidetracked, let's go back to this.
Relegated to a dusty shelf for more than 40 years was a fossil that bore an uncanny resemblance to Tyrannosaurus rex.
I don't think it was on a shelf. I think this thing was literally on public display and like millions of people saw it. I don't think it was on a dusty shelf. I think they're saying that. I think they're just saying that for narrative's sake here, you know?
Barker renamed it Nano-Tyrannus, the pygmy tyrant.
Yeah.
Now, the really neat thing about this head is that it's a downsized version of the most famous dinosaur in the world. That is...
Hang on. Casey Snort says, do private individuals or for-profit digs ever do a good job of collecting stratigraphic data? Sometimes, yeah. Yeah, it's not... I would say it's not common. Shoot, there are a lot of academic paleontologists who don't necessarily do a great job of, collecting stratigraphic data and that kind of thing. But, yeah, for the most part, commercial groups don't. That's kind of what they're notorious for. When data is overhead, you're not going to collect data. You know, when you're a for-profit enterprise like that, that's cutting into your profit margin. So you're just not going to do it, you know?
Tyrannosaurus rex.
Yeah.
Now you look at
anyway.
Head, is that it's a downsized version of the most famous dinosaur in the world. That is Tyrannosaurus rex.
Most paleontologists, most theropod workers today agree that this is a juvenile Tyrannosaurus rex. That's why it looks like a downsized version. But, yeah.
Now you look at T-Rex. You've got an animal with a head 4 feet long, with a body that's 5 or 6 tons. Nano is a close relative. A head only as big as a polar bear, a body maybe 600 pounds, pony size. And yet the little dinosaur and the giant dinosaur share the same architectural stamp. You look at...
I would say it's because of the same thing. Anyway, this isn't going to be particularly relevant what Bakker's saying right here. But, to our conversation. The original holotype specimen, the name-bearing specimen for Nano-Tyrannus is the Cleveland skull right here. This is my 3D print of the Cleveland skull, which is why I can have it here in my office. It's, as we're fond of saying, real important, scientifically valuable fossils,
That belongs in a museum!
Yeah. That's why I have this here. And why it's not in a museum is because this is a 3D print that I put together myself. Based on a scan of the original. Anywho, there's kind of a broad consensus nowadays that Nano-Tyrannus is not different than Tyrannosaurus. It's a juvenile Tyrannosaurus. However, there were rumors floating around at the Society of Vertebrate Paleontology conference that I was at the end of October, beginning of November, that somebody may have actually grabbed and found a hyoid bone. So, like, one of the bones in the throat, these kind of bones that are... Here, hyoid bone is, in people, it's right there, the hyoid bone. Kind of a delicate bone like this. There's rumors that they've got this in the Cleveland skull, and that they did a histosection on it. So they actually cut it open to count the growth rings inside, and it's an adult. It would have an EFS, an external fundamental signature, which would imply that Nano-Tyrannus is actually an adult and distinct from Tyrannosaurus. Not a juvenile Tyrannosaurus, but something different. So I'm eagerly awaiting the publication on that. We'll see what comes of that, but that's the rumor right now. So yeah, we shall see. I don't suspect that Nano-Tyrannus is valid, but shoot, if they've got an EFS, an external fundamental signature showing that this thing is mature, is full grown, well then shoot. Looks like we might have another Tyrannosaur in the Hell Creek Formation, which is really exciting, potentially. We'll see. We'll see, because the evidence has definitely been leaning away from that in recent years. So yeah. And Squiggles says, wait, so you don't have that bone when prepubescent? No, you do. The bone's there. It's just not going to be mature yet. So the way that we can determine whether a dinosaur was young or old is doing what we call histology. So you cut the bones open and you look at the growth rings inside, like we got here.
Hi, my name's Lisa Herzog. I'm in the paleontology.
Histology.
The specimen's off display. One of the things we are doing with it is
this is an Acrocanthosaurus femur here
on the specimen to help with the body of research.
Growth lines like we see on trees,
animal. The process we're doing is called creating a histological slide, or it's also known as histology.
Yep.
Which means that we're going to be looking at the specimen on a microscopic level in cross section. So what we have to do for that is cut the specimen in half. Before we go through this whole process, we consult with other members of the department to make sure that this is a worthwhile venture, because it is a destructive process. So I've already gone through the first step of this process. I cut the bone in half, and then I cut a section out of it.
Tomato,
and
potato.
Here's what it looks like now. After this section was cut out, this little slice, I embedded it in a clear epoxy resin for stability.
Yep.
I'm going to be polishing this real smooth and gluing it down to a slide. And then we're going to polish it even more so it's very, very thin and
you can shine light through it.
We can look at it with light transmitting through the slide on a microscope.
That makes sense.
You can see the cellular structure of the bone. One of the things that this can
instructive
tell us
sampling.
Is
there you go,
how
yeah.
An animal grew, if there's any sort of pathologies, meaning if it had any kind of diseases, it'll show up in its bone, and it'll help us understand how old this animal might have been when it died.
Yes,
was
indeed.
it really, really old? Was it a teenager? Was it still growing? We can tell that by looking at the specimen in this way.
Yep.
This is actually a pretty common method in paleontology.
Not as common as I would like it to be. We need so much more of this on so many more specimens. And, yeah.
Especially for this type of dinosaur. So one of the things we're planning on doing with the dueling dinosaurs is processing the Tyrannosaurus.
Yeah, so at the North Carolina Museum of Natural Sciences, who produced this video, they've got a potentially juvenile Tyrannosaurus, or is it a Nanotyrannus? There it is right there. It's in beautiful shape, too. It was a commercial specimen found by a commercial collector. It was sold for something like $10 million. Something crazy like that. So is this a juvenile Tyrannosaurus, or is this Nanotyrannus? They've presumably done histo on this already, and they're just kind of sitting on it right now. They haven't published it yet. But it is going to be... whatever results they get are going to be very important. So we'll see. We'll see. Anywho, I hope that makes sense. Yeah. Why don't we get into... oh, shoot, I still got to post a Blue Sky. I was talking about stuff from this weekend. Yeah, the holiday party at the Museum of Paleontology at Berkeley was a lot of fun. And Lordy helped me to make some coelacanth cookies, which I think turned out pretty well. Yeah. They look great, says Nice Chert. Well, they're not even done. Here. These are produced with a cookie cutter of my own design. Right here. Many of you were here when we printed this live on stream last week. But here is the finished product. right here. I had to print it larger than I was expecting because we just kept getting gaps in it in certain critical places when I tried to print it smaller. So we had to use the slicing software to really size it down, but I think it turned out pretty well. Ended up with some decent cookies there. And already helped me decorate them too. But yeah, and we ended up getting 3rd place in the baking contest, and there were like 15 entries. So we did pretty well. Yeah, Lordy always makes excellent cookies. She's actually got a degree in baking. So she went to school for this. In baking, not in decorating. She's like, I hate decorating. Danny, can you help me with frosting these? And I said, yeah. Anyway, next year, I'm going to be making some improvements to the cookie cutter. Might even do that sooner rather than later. Because some of these are just too small. Like this aperture right here, for that fin right there. The second dorsal fin, it's too thin right here. And so these have a tendency to break off. Same for here and here also. So I'm going to be making some changes to that. And, yeah. And then once that's done, I'd like to be able to put the file up for free somewhere so people can download them and print them themselves. Kind of spread the coelacanth love around. Yeah. Cookie cutter of a cookie cutter shark. It would be so meta. I like that, Shark Geek. It's one of my favorite sharks. Cookie cutter sharks are not very distinctive in their shape, though, are they? I think they're kind of nondescript. Yeah. I mean, that silhouette would almost look like a Pacific sleeper shark or something. Especially when you've got it as a cookie cutter, you know? Maybe. Well, yeah, I don't know. That's real thin along the tail, though. It's difficult to design a good cookie cutter for a critter like that. Yeah. Anyway. But yeah, good stuff. So this was a lot of fun. Speaking of 3D printing, by the way, with the 3D printer, got something to show you, chat. You ready? Here goes. I've put my 3D printer next to a mirror, so it looks like I have two. I'm just kidding. No. That's not next to a mirror. There are two 3D printers there. Two 3D printers. Very bad mirror, says Squiggles, yeah. I decided to invest in a second 3D printer so that I can print twice as fast. I figured it's about time that we started doing that. And, I'll be talking about why tomorrow. We've got a very special announcement tomorrow. Special announcement stream, December 10th, right there. I can't tell you what it is yet, but this will be important for that. Sort of. I'm really excited. Some of the moderators already know about this, but there's some exciting things going on. There's some exciting things going on. And I'll be talking about it tomorrow. So make sure you tune in then if you want to see that. Good stuff. Very good stuff. Right now, I'm printing something kind of just for fun, for me. Alexander Morrison, I think, might be particularly interested in this. Let me grab some pieces of it here to show you. Some of these still have the supports on them, so it's going to be a little bit difficult to decipher what it is, which is fine by me. But this is kind of a big project. It goes twice as fast now that I've got 2 3D printers. All right. Put this on like this. And then take this piece off. It's not going to be easy to balance there. And then this. And this. Holy cow. What is that? Yeah. I'm working on printing the rest of it right now. We might even have it done by tomorrow's stream. We'll see. But this is indeed a gharial. Gavialis gangeticus. The Indian gharial. I am printing a complete skull and lower jaw of one of my favorite critters. There's the supports on here. If I were to remove these, you could see the teeth, and it would be a lot easier to spot. But you can kind of see them there. But we might be assembling this on, let's say Wednesday. We'll be assembling this. And we'll talk a little bit about gharials on Wednesday too. So let's add that to our gharial skull assembly. There we go. Good stuff. That'll be a lot of fun. That'll be a lot of fun. My boy here finally adding Sukians to his print collection. I've already got a couple of Sukian elements. I've got a nice osteoderm. I don't know if I've shown that off on stream yet, have I? But I've got a nice big osteoderm from a croc that I 3D printed a while ago. But anyway, good stuff. Yeah. And Duster says, how does the gharial compare to a Nile crocodile in terms of size? I think they're similar length, but not as heavy. So yeah. They're one of the largest living crocodilians. Yeah, gharial. Among the longest of all living crocodilians. Mature females are 2.6 to 4.5 meters, so 8 feet to 15 feet long, basically. And males, 3 to 6 meters. 9 feet to 19 feet in length. So they get to be a really similar length to a Nile crocodile, but I don't think they're as heavy. These are the most aquatic of modern crocodilians. We'll be talking about these a whole bunch on Wednesday. We're going to go in depth on gharials. Yeah. Let's see. Can reach a weight of up to 1,300 pounds. Let's see what it is for Crocodilus niloticus. Crocodilus Niloticus, the Nile crocodile. Mm-hmm. 2,200 pounds in weight have been recorded. So yeah, Nile crocodiles definitely get a lot heavier. Yeah. But they're around the same length, maximum size. Yeah. Pretty cool. Pretty cool stuff. Anyway, we'll be talking all about gharials, I'm sure, on Wednesday. Maybe we'll catch up on some fossil news, too. Check them out on the One Zoom Tree of Life. We should, Lenina, you're right. Let's pull that up here. Anyway, we'll jump from sand tiger shark to Gavialis, Gangeticus, Indian gharial, or fish-eating crocodile, as it's sometimes known. Right there. Yeah. And holy cow, Fluke, thank you for the 5 gift subs. I really appreciate that. Thank you, thank you. Holy cow. Flug. Appreciate you.
Just changed things with those 5 gift subs.
Thank you, thank you. It's 5 very lucky people in the chat who won't have to watch any ads until January 9th. 1 month from today. Flug, I appreciate your generosity. And thank you for kicking off the race to our sub goal for the week. We've got 4 days to try and get to 150 new subs. We are 1/30th of the way there now. Thanks to you, Flu. Appreciate you. Excellent. Yeah. But here we go. Fish-eating crocodile. Gavialis gangeticus. And, my goodness, look at this. Sponsored by Danny Anduza, Paleontologizing on Twitch. Thank you, moderators and community members, for helping make this possible. I believe Lenina was leading the charge here. Thank you, Lenina. That makes me really happy. When did that happen? I know. Right, Lenina? Holy cow. Yeah. Amazing. Very well. I appreciate you, Lenina. Holy cow. Good stuff. Good stuff. So I'm sure we'll be showing this off a lot on Wednesday. Yeah. So we've got some exciting things going on this week. Again, we're catching up on some fossil news today. Tomorrow, very, very special announcement that I've been waiting almost a year to reveal. Very exciting stuff. Very exciting stuff. Gharial Skull Assembly on Wednesday. Thursday, of course, is Thursday Birds Day. So yeah. Very exciting. Yeah. Alexander says Thornyarbsoni and Anthropophagus. Anthropophagus, that's such a cool species name. It's like, yeah, this is a people eater. They're extinct species of crocodiles. Both species reached around 5 to 7 meters. Lived alongside the Nile crocodile. Very cool. Thornyarbson is Thorbjarnarson. I was drafting up an email to him at one point.
Welcome to another edition of Lifestyles of the Large and Extinct.
Kiba666, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. What was his name? Was it John? I forget his first name, but I was drafting up an email to him for a paper that I was working on. This is probably about a decade ago. And I was just about to send it. I was like looking for his email address. Like, this is a guy who's an expert on crocodiles, including gharials. I want to get his advice on something. And I looked him up and trying to find his email address. He had just died like 2 years before. There we go, yeah. John Thorbjarnarson. I think he had died of malaria. doing field work. Yeah. Thorbjarnarsson died of falciparum malaria. Hope I'm saying that right. On February 14th, 2010. His family set up a foundation for the Wildlife Conservation Society. 52, just before his time. Ugh. I was pretty disappointed to hear that. You know, vertebrate zoology lost a great researcher that day. Yeah. Anywho, yeah. And Salamander says, my mom is making demands of a 3D print as a gift for being such a dedicated, unwilling secondhand viewer of the stream. We could talk about that, Salamander. That might be fun. But yeah. Anywho, let's get into some fossil news here, shall we? Oh, first we gotta post the blue sky. Yeah. Let's just do a real quick one. Let's see, control print screen. Like that. Do some screenshots here. We'll see if they're usable. Let's go down another rabbit hole first. We're trying not to, DM Wang. We're trying not to. I'd like to be able to actually get to some of these cool pieces of fossil news. But first we gotta do some homework here. Housekeeping, rather. Let's do 400 DPI. Paste. There we go. That'll work. Let's go ahead and save that. Nice. New post. Okay. It's a real hodgepodge. Channel lag. Assortment of stuff. Office wall today. As we go over some paleontology news. And newly published papers. Say hi in the chat. Twitch.tv/paleontologizing. And let's do alt text. Me in front of a Santa hat wearing Monkeysaurus. Plastic model. A 3D printed Dimetrodon skull. Papercraft coelacanth. Various frame prints of scientific figures. On the office wall. Okay. There we go.
Hold on to your butts.
Post. Copy link to post, and there it is. Chat, if anybody would like to engage with that post for whatever reason. Which people are already doing. Thank you. Hip and Lenina and Tommy Platicus, I appreciate you. Holy cow. Yeah. It's so much fun having changing out everything in the background every day, and I'm really glad that I've got an avenue to share that, not just here on Twitch, but also elsewhere on social meteors, on Blue Sky too. That's fun. Yeah. It is fun, Lenina. Yep. Keeps things interesting, you know? Yeah. Notogoronopsid skull. This is Dimetrodon right here, DM Wing. Yeah, Dimetrodon. I do have an Inostrancevia skull. I have files for that. I'd like to print it at some point, but hasn't happened yet. Yeah. Anywho, yeah. Good stuff. Alright, good to have that done. Now let's get into some fossil news here, shall we? Without further ado, here comes fossil news. All right, our first item on fossil news today. Got some 95 million year old fossil tracks found in northeastern British Columbia, says paleontologist. This is why we've got. This is from Australia, potential stegosaur footprint. Lulu Ichthys is the genus name. This is why we've got a fossil footprint on the wall today, in anticipation of this. Track may have come from a very big bird or else a bird-like dinosaur. I like that. It shows just how difficult it is to determine sometimes who's leaving those tracks, and also it's a wonderful illustration of how similar some of these dinosaurs were to birds. My first thought is that this is from an ornithomimid. From a critter like this, what we sometimes call ostrich dinosaurs, or bird mimic dinosaurs. These guys were very, very bird-like. But they're not even the most bird-like of all the theropod dinosaurs, certainly not. But ornithomimids, many of them have lost the digit 1. Like, they don't have a hallux anymore, they don't have a first toe. So they've just got the 3. Birds today, most of them have got a hallux. So you've got the 3 toes there, and then there's, say this is the right foot, and then there's that toe right there too. So like, Tyrannosaurus hind limb. show you. Right there. You see the little, you can almost call it a dew claw. That's the digit 1 claw right there, aka the hallux. That's equivalent to like your big toe. So most theropod dinosaurs have this, but some of the ornithomimids, maybe all of the ornithomimids, lose it. In fact, I want to look that up real quick. Ornithomimidae. There we go. Hallux. The word doesn't show up here. Okay. This is not as comprehensive an article as I would like to see. Let me look up a more quote-unquote primitive ornithomimid, something like Peleontologizing.
The biggest question of all surrounding the dinosaurs is why?
Why? Vengeance God, thank you for the raid.
46 raiders have arrived to ask exactly that question.
Welcome to Paleontologizing. It's wonderful to have you here. How are things? Street saying there's dinosaurs here? Don't always listen to what the streets say, but in this case, they are very much correct. In fact, that's an understatement. Are there dinosaurs here? Holy cow, yes. Cure Cow, welcome to Paleontologizing. Vengeance God, I hope you had a wonderful stream. Welcome, welcome. Behold the kings of the Star Trek Online Raiders. Welcome, kings. I'm glad you're here. Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. So as a paleontologist, I study fossils. I publish on fossils in the scientific literature. Almost always dinosaur fossils, so far. And Reese, thank you for gifting Vengeance God. I appreciate that, Reese. Thank you, thank you. Yeah, dinosaurs are what I study, what I publish on in the scientific literature, what I dig up during the summers. This past year, we were lucky enough to do about 2 months worth of field work in Wyoming and then in Utah. Digging up dinosaurs and streaming it live on Twitch. It's such a privilege to be able to do this kind of outreach, you know?
And I'm excited to show you around a little bit. That's the whole point of these live streams, is to be able to do some science outreach, you know? To kind of walk you through our work as paleontologists. You've probably seen dinosaur digs in the movies or on TV or in books and stuff.
We picked a good spot here.
But rarely do people actually get to watch that kind of thing live, and that's why I'm so excited to share this with you. This is day 11 being out here in the field. Day 10 of actually digging. And we've got bones coming out left, right, and center.
Yeah, let me scoot forward to we're actually doing some excavation here. So this is what I do during the summers. Yeah. But anyway, when I'm not in the field, usually right here in my office, going over new scientific discoveries, talking about new papers, fossils in the news, that kind of thing, answering people's questions, all that good stuff. BHS Usaris says, we have superior dinosaurs in the Star Trek Online universe. Right, Kale? Do you know? Well, what's funny is, one of the people I work with in the field, Utah's state paleontologist Jim Kirkland.
Really spectacular, spared no expense.
Mark Melbourne, thank you
Melbourne gifted a tier 1 sub to
for gifting BHS. I appreciate
they have given
that.
137 gift subs in the channel.
Jim Kirkland, the state paleontologist of Utah, is actually author of a Star Trek novel. Let me see if I can find, let's go to transcript. Here we go.
If you're feeling a bit cheated, try blaming the dinosaurs.
We've got some Star Trek fans in the chat for sure. Do you want to talk a little bit about your novel and?
Okay. Well,
Back when I first announced Utah Raptor, I got a call from this woman, Diane Carey. Well, how do you know those things might have been hers? I said, well, pack hunting. I said, there's a couple sites where they've got a number of Deinonychus together relative to Tyrannosaurs.
There you go, Salamander. Yes. Yes, we'll talk about that.
Item. And we think, they were hunting this animal and, being bigger than they are, killed a few. We have good evidence of, many wolves getting killed by bison.
Sure, yeah.
During, it's a hard way to make them have lunch when half your friends die in the process. But, that happens. Watch it takes you out to lunch. You may be a decoy. But Diane, we're talking about this stuff, and I'm explaining, it's theoretical. We don't know 100% for sure, but it seems there's some
the Star Trek, too.
Maybe they were.
I pulled up this
she goes,
clip.
Well, have you ever read a Star Trek novel?
There we go.
No. And so I've written quite a number of them. And I said, oh, cool. Sitting around the campfire, we came up with a scenario. Wouldn't it be funny if, like the Gorn, went back in time.
I don't really know what this is,
and
but
prevented the asteroid from hitting the Earth, so the Federation would never be. Humanity would never take center stage in the universe, and the crew has to go back from some way and make the asteroid hit the Earth, and they discover dinosauroids and save the dinosauroids. Because Kirk's such a good guy, and it turns out when they plant them on a different planet, they become the Gorn in a few hundred, 100 million years. So everybody's kumbaya, hugs and kisses, And she goes, "Wow, that's kind of a neat scenario. You want to do it?" I said, "Sure, let's do it." So we wrote this novel together.
What was it called?
I got that right here.
First Frontier.
First Frontier.
Yeah, original series number 75.
There it is right there.
75. Got the entire Star Trek.
Diane Carey and Dr. James I. Kirkland.
But anyway, there's a picture of Kurt and Spock.
And I had Jim sign it for me.
Phasers, and a raptor right behind them, ready to rip their heads off. But, of course, Spock meets T-Rex, the Bond.
Do the mind meld thing?
Yeah. But they made this group, and they couldn't, the lawyers for Star Trek wouldn't let us use the Gorn. And, of course, they have silver-faceted eyeballs, but they sure changed the Klingons a lot, so it's like, that shouldn't be an issue, make the Gorn.
Add that to your collection. Nice, Otter, yeah. Here, I'll give you a link to this particular timestamp here, too, just in case. I want that also. But, yeah. Anywho. How long ago was this? That was 3 summers ago, I think. Did that interview with Jim, but yeah, that was back before I had satellite internet. We were doing everything via mobile data at that point. This year I did a couple other sit-down interviews with Jim. He was in the quarry with us a whole bunch. There we go. The videos, so yeah. And Jim frequently shows up here in the chat also. Yeah, here we go.
A lot of terrestrial Mesozoic rocks, maybe.
It's Jim. He's like a dinosaur Santa.
Yeah.
What was that somebody said?
Not as common.
Let's see, Snapping Neuron says, I think in reference to Jim, he's like a dinosaur Santa.
Yeah. What happens after 50 years?
I don't know. I think Jim knows a lot more about dinosaurs than Santa Claus knows about Christmas. So. Yeah. Anyway. Yeah. And BHS says, consider yourself an ally to the Katomer Alliance. Thank you. I am honored. I appreciate it. Thank you for being here. Thank you again, Vengeance God, for the raid. Since we've got you and BHS and presumably some other really cool people here in the chat too, who are brand new, I think it's a good opportunity to maybe call forth a good friend of ours, somebody that we like to call Previously Recorded Danny. He's going to tell you a little bit about who I am, why a paleontologist is here on Twitch in the first place, and all that good stuff. So without further ado, I will leave you in his very capable hands. Previously recorded Danny, it's your time to shine.
Well, thanks, present-day Danny. Well, if you're new here, then welcome to Paleontologizing. You might be wondering to yourself, where's the video games? Well, my name's Danny Anduza, and I'm a paleontologist. I don't really do too much in the way of video games, I guess. I work on dinosaurs. But how does a paleontologist end up on Twitch? Well, I'll tell you. It all started when I moved to Montana right out of high school. In my first week there, I started working in the Paleo Lab at Museum of the Rockies, which at the time was probably the greatest dinosaur museum on the planet. If you've ever seen any of the Jurassic Park movies, then you're more familiar with that institution and with my old boss than you may realize.
You consulted on that movie.
I did consult on all those
movies. And they
movies.
said the guy, Alan Grant, was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
It was in that program that Jack Horner built that I learned how to be a dinosaur paleontologist. I learned a lot of that from Jack Horner's last graduate student, this guy, Denver Fowler, who would go on to become curator of the Badlands Dinosaur Museum in North Dakota. Under Denver, I did nearly a decade's worth of fieldwork, digging at hundreds of sites in the Upper Cretaceous, excavating literally hundreds of dinosaurs. Here's just a few highlights. In 2012, I discovered the world's oldest specimen of Chasmosaurus, hopefully soon to be published as a new species. In 2017, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, we found parts of its armor and plates, and so it should be a new species.
I've also been lucky enough to help collect another very important specimen, the world's smallest and youngest Tyrannosaurus rex. And much like my fieldwork, my research is also centered on dinosaurs. Some of that deals with new genera and species, like this guy, Trurarchuncus, a bizarre little theropod from the very end of the age of dinosaurs, who was just published in July of 2020. I've got a few studies in the works right now, some of them focusing on dinosaur biogeography, and some others on behavioral functional morphology, basically looking at bizarre features of dinosaur skeletal anatomy and trying to figure out why those features evolved. And one of my current projects involves spinosaurs. But I can't really talk about that until it's closer to publication, so don't ask me about it yet. Anyway, let's get back to how I ended up on Twitch. A couple years ago, things were definitely on the decline in Montana, so I packed up and moved back to the West Coast. And I have been so much happier here. I've also realized that I have very little patience for the soul-deadening bureaucracy within academia. So for the time being anyway, I've moved my career in a different direction. And lucky for me, it happens to pay a lot better too. I kind of stumbled my way into a job in early childhood education. I get to make a real difference in kids' lives and help instill a love of nature and a burning curiosity for the world around them. Then coronavirus descended, and the school shut its doors. But I wasn't about to let a global pandemic stop me and my students. We just moved online. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush, because the treasures that I see are rare and ancient things, like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. Having made the jump to teaching remotely, it was only a short leap from there to Twitch. I started streaming in May of 2020, and it's been tremendously rewarding. Now, it's my belief that any good scientist should also be a public servant. In my opinion, talking to everyday people about your science is one of the most important things a researcher can do. Twitch is kind of an ideal medium for that. This is my passion, and now I get to share it with you. And what could be cooler than that? It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help out by continuing to watch, or if you can afford it by subscribing, I would be deeply grateful. So, for my regular viewers, thank you for sitting through that again. And for everybody who's new, welcome. We've got a fantastic little community going here, and we'd be really happy if you'd join us. Anyway, let's go ahead and wrap this up and get back into it. So, present day Danny, back to you. Well, thank you very much, previously recorded Danny. Of course, thank you even more to Vengeance God for the raid. I really appreciate it. Welcome, welcome. Let me know if you've got any questions. And Sky Cricket, thanks for the follow. Howdy, howdy. I'm glad you're here. Welcome to Paleontologizing. And Chino JS, thank you for the sub there, the Prime. I appreciate it.
Because
good stuff.
If they're removed, America loses them forever.
Thank you, Chino JS. Thank you very much for the Prime. Appreciate it. Some of our alerts are working now, actually. But the Prime and the first-time subscription and the raid alerts weren't working for like the past month, and now they're working again, and I'm really happy about that. It's got to be like a Stream Elements bug. I was this close to spending like a whole day this weekend moving all of my alerts to the Twitch native alert system. Now it seems I don't have to do that eminently, so that's good. Anyway, I appreciate you, Chino. Thank you, thank you. And Salamander says, calling back to the conversation about largest birds earlier. Just what did pterosaurs do so much better than birds to have reached so much larger upper sizes? That's a good question, Salamander. I'm not sure. It might be that they had longer to get bigger. Because pterosaurs were around for what, like 150 million years? And they could kind of get gradually larger over time. That might be part of it. It might be like a Cope's rule kind of a thing, you know? Just larger body sizes over time. Birds have been around since 150 million years ago, since the late Jurassic, but they've gone through a huge bottleneck, where at the end of the Cretaceous, just 66 million years ago, almost all of the bird species got wiped out by the same asteroid that wiped out their non-avian dinosaur cousins. And so that could be part of it, I suppose. I'm sure that's a factor. But I doubt that's all of it. I don't know why the biggest pterosaurs, the biggest flying pterosaurs, got so much bigger than the biggest flying birds.
Really spectacular, spared no expense.
And thank you, Reese, for gifting Ursa Mesa. I appreciate that, Reese. Thank you, thank you. Good stuff. Ursa Mesa, enjoy not having to watch any ads for the next month. Thanks to Reese there. And look, we're up to 1/15th of our weekly sub goal. Thank you, Reese, for your generosity. Yeah, the biggest pterosaurs that ever lived are critters like this, like Quetzalcoatlus. And they did get very big indeed. Holy cow. Like this big compared to me. Whoops. That was Nick Hornacek, who was on our field crew. I asked him to take a video of me with the phone, and he's just like taking selfie pictures. He did that during the field season too. Should delete that. Anyway, these guys are really big. Really, really big. It's impressive how big they were. You know? That's just what good friends do, Danny. I guess it's true, Reiko, yeah. Yeah. There's Colin and there's Spencer there. Worked with these guys in Wyoming this past year. But yeah. Anyway, these guys were incredibly lightweight. Their bones were the same dimensions as oh, here. Let's have the man himself tell us.
Berkeley paleontologist Kevin Padian is an expert on the evolution of flight and the anatomy of pterosaurs.
Yep.
First thing to know about pterosaur bones is that they have the thinnest bones of any vertebrates. This
Thinner
one's
than birds.
squashed completely flat as a pancake. And it's like it was just like it was run over by an 18-wheeler sometime in the Cretaceous there in the middle of the ocean, right? And it's a this bone comes from the upper arm like this. It's squashed completely flat. The bone wall is so thin, it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir in it. Well, that's what this thing is like.
Yep. Yeah. Incredibly thin bones on these critters. Incredibly thin bones, which is why an animal like this could still take off from the ground. You know? It's cool to think about. Call it the middle of a toilet paper roll. That's funny, Charlie's trying. Those are Danish subtitles. Interesting. That's really funny. Yeah. Som pepret fra en toiletroll. I probably butchered that, but yeah. Oh, good stuff. Yeah. Anywho. Yeah. Where were we? Oh, let's get back to our fossil news here. There, we were going to talk about this. And that was Danish, says Steph Meowie. Was it? I don't know. I don't speak Danish. The paper pipe of a toilet roll. Yeah. Interesting. Well, he didn't say toilet paper. He said paper towels. Remember? Close enough. I guess that would be like the carbine version of a dirter if it's from toilet paper roll. Anywho, Steph Meowie, it's good to have you here. Does that mean the bones could easily break? Probably not. They're engineered in a way to make them really, really strong. Engineered, rather, they evolved in such a way to make them extremely strong. There.
Berkeley Cretaceous there in this dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir in it. Well, that's what this thing is like. Dirter. Yep. Except there's nothing in the middle of it. I mean, it's just completely air-filled, and it's squashed flat, and the bone walls are very, very thin. Now, you might think this would make it a very weak bone, but in fact, we checked this out with some engineers at Stanford, and we're working with them, and they showed us that, in fact, the big diameter of this arm is what really makes it strong.
Despite its hollow center, the thick...
I kind of wonder whether it's sort of like an egg, where it might be something about the roundness of the cross-section makes it stronger than it would otherwise be. Yeah, impossible egg crush experiment. Like, if you take a chicken egg, put it in your hand like this, and you try and crush it, most people can't do it. Just because that particular shape, the roundness of it, kind of distributes stresses around the perimeter, and it doesn't really have any corners. Corners are usually the weakest part of a structure like this. And so because it's round like that, it's very strong. So it might be something like that, you know? Or like a stone bridge holding itself up. There you go, Stephanie. Oh, yeah. Yeah. Does that make sense? Yeah. Anywho. Let's get back to what we were talking about earlier. Man, we're 2 hours into the stream and we haven't covered any fossil news yet. Let's do this. Here we go. 95-million-year-old fossil tracks found in northeastern British Columbia, Canada. Says paleontologist. Track may have come from a very big bird or else a bird-like dinosaur. It looks very bird-like like this, but as we were talking about earlier, we've got some very bird-like dinosaurs. Dinosaurs with very bird-like feet at the time. If this had come from an ornithomimid like this, I wouldn't be shocked, you know? It doesn't seem to have a hallux, but this isn't a complete picture either. Paleontologist Charles Helm says the fossil tracks, known as Magnoavipes, this is what we call an ichnotaxon. Sometimes there are names that are given to fossil footprints or fossil burrows or other trace fossils like that. It's not a name for the animal that left them, it's a name for the trace itself. So this particular morphology of track is called Magnoavipes. It's an ichnotaxon. Ichnotaxon. A taxon based on the fossilized work of an organism. I.e. the non-human equivalent of an artifact. That's interesting. So this is Thalassinoides burrow fossils. So it has a scientific name, but it's not a name for the animal, it's a name for the trace. These things are given names like this so it's easier to communicate with other scientists what you found in a given place. Because sometimes you'll find the same structure in another part of the world. And so giving that structure a name helps with communication like this. You know? Charlie's Dragon says Magnoavipes equals great bird foot. It's what it says on the box. Yes, indeed. Here, ichnotaxon. If you want to read more about that, here is a link. But yeah, Magnoavipes, it really does look like a big old bird track. Compare that to one that you might see on the beach. You know, something like this. Some of these have got a proper hallux, so like the digit 1 toe, the first toe pointing backwards like this, but some of them don't. Like that one. This could be from a crane or maybe a heron or something, a non-perching bird. They typically don't have the hallux anymore. They've gotten rid of it. They've only got 3 toes instead of 4. But that looks pretty darn similar to this. And if you gave me long enough, I could find some pictures that would be like almost identical. But yeah. Verity, how are you doing? Welcome to Paleontologizing, Verity. You've raided into your channel a few times. I met you at TwitchCon this year. That was a lot of fun. Meeting you. I hope you're doing well. It's good to see you. Welcome back to Paleontologizing. Today we're just kind of catching up on some fossil news. I've got a very important and exciting announcement for tomorrow, but for the time being, we're just doing some fossil news right now. Oh, and hello, Moon Pie. How are you doing? Do you want to come up here? Oh, holy cow. Come here, Moon Pie. Are we going to have 3 cats on the stream today? All 3? Come here. Come here, Moon Pie. Could we be so lucky? This almost never happens. Yes, indeed. Well, well, well. Moon Pie, how are you? Wow, we almost never get to see Moon Pie. It's very difficult to bribe her to come up onto the desk because she doesn't like treats. With Mini Pie and Sweetie Pie, it's much easier to get them to show up here. Permit me to demonstrate. We have one of those leftover treats right here. Moon Pie, can I offer this to you? Would you like a treat? Here. Look. Is that there for you? She's smelling it. She's like, nope, no thanks. Oh, okay, Moon Pie. Okay. Yeah, but yeah, we've got a cat trick today for the first time in a long time. All 3 cats in one stream. Well, well, well. So Moon Pie, along with the other 2 cats. She's one of my landlords here, huh? Yeah, I gotta make sure I keep you happy. I can continue living here, huh? Yeah. Moon Pie's the oldest of the 3 cats. And, she's got kind of a short nose. As a paleontologist, I would say she's got the brachyrostron condition. Oh, and there she goes. Kind of a squished-in nose. Lordy and Ios and I sometimes joke she looks like a bat a little bit. Like a micro bat. It's short noses. But yeah. Suavorio says, I'm sure there's a different treat she'd love. My cat is also picky. I don't think it's that. I've never seen her eat any kind of treat. I think it might be a context thing. I think if I were to put a bunch of treats into a bowl, then she would recognize them as food for her and she would eat them. Because she has tried to eat dry cereal out of a cereal bowl before on numerous occasions. So I think it might be context dependent. If you put the stuff in a bowl, she might try and eat it. But otherwise, she's just very suspicious of it, you know? Yeah. Anyway, yeah. Oh, where'd you go? Oh, she's over there. Okay, cool. Anyway, let's get back into our news here. This should just be a really short one. We don't have a scientific paper associated with this yet, just a press release. Paleontologist Charles Helm and geologist Roy Rule, they did author a paper, well, on their discovery of a track last year known as Magno-Avipes that dates back to the late Cretaceous. Magno-Avipes, which translates to big bird foot, as a genus classified based on fossilized footprints rather than bones. This is what we call an ichnotaxon, like I was telling you about earlier. Helm told CBC News that the track was likely left behind by either a very big bird or else a bird-like dinosaur. It's difficult to know for sure which of those two, but if it were a bird, I mean, it was big, he told CBC's Daybreak North. Helm said only 3 Magno-Avipes tracks have been discovered in Canada, all within the district of Tumbler Ridge. The first fossil was found there in 2010, while 2 others were discovered in 2023. The largest track was 25 centimeters in length and 28 centimeters in width. And for all of our uncouth, non-metric Americans in the chat, myself included to a certain extent, 25 centimeters in length is that long. So it's a decent-sized footprint there. Especially if it were from a bird. Holy cow. That'd be a large bird. Helm said he and Rule discovered the tracks last year, thanks to a bit of good luck. And they've done a nice scan right here. Ooh, I wonder if this is available in the supplemental info for the paper. If I could download that and 3D print it, that'd be pretty cool. Yeah. The track was spotted in a loose slab of rock following a cliff collapse. Helm said that it was fortunate the slab didn't shatter in the collapse and that it landed upside down, revealing the track. Low water levels on the Wolverine River during a dry season meant the slab was exposed for a prolonged period of time. It was just lying there, you know, next to the riverbank, he said. That's actually kind of common. A lot of you probably saw some news reports about dinosaur tracks exposed, was it last summer, I think? During a drought in Texas. Yeah. Riverbeds are often a good place to find dinosaur tracks. He said the team of 4 transported the 150-kilogram track-bearing slab by canoe across the Wolverine River and then by truck to the Tumbler Ridge Museum, where it currently resides. Derek Larson, collections manager and researcher in paleontology with the Royal Tyrrell Museum, the Royal Museum of British Columbia, not the Tyrrell, that's in Alberta, said the fossil track appears to be quite a bit older than a lot of the other fossils seen in Canada. It dates back to the Cenomanian stage, which he described as a very interesting time period that we don't know a lot about, especially in Canada. Yeah. The Cenomanian is the last holdout of the Spinosaurs before they go extinct. There are some other dinosaur groups that blink out at the same time. There's probably something happening. Like, we've got some faunal turnover going on at the end of the Cenomanian. Important stuff. The most interesting thing about this print to me is that we still don't know exactly what it is, Larson said. There might be a giant winged bird in the Cretaceous that we have no bones of just because we don't know enough about the fossils of that time. We have these very tantalizing footprints that are showing that there is something here that's leaving these footprints. That encourages me as a paleontologist to go out and find it. Helm feels the same way. He said he plans to return to the area and continue exploring. The Tumbler Ridge area, things are coming and going all the time, he says. Cliffs collapse, floods open things up or take things away. Things are ephemeral here, so we have to keep our eyes open. He said they would love to find a Magnoavipes trackway, which could help them identify a new species. Wouldn't it be nice if we could actually find a trackway of 2, 3, 4, 5 tracks in a row, and then we can work out the stride length and the pace length? That's the holy grail. Cool stuff. Here's a link to the press release right here. And then here is the paper in the journal British Columbia Birds. Journal of the British Columbia Field Ornithologist. In press, so it's, I guess, not been peer-reviewed yet. Magnoavipes, big birdfoot, tracks in the late Cretaceous near Tumbler Ridge. I don't think I'm going to have access to this. Yeah, I'm not a BCFO member, but if any of you in the chat happen to be, here's a link for you. Cool stuff. Fossil footprints like this can be really, really important because rather than body fossils, which represent an animal that died, these also represent an animal that died because it was a long time ago. Whoever left these tracks is no longer with us. But this is a record of behaviors during its lifetime. This theropod, whether it's a bird or a non-bird theropod dinosaur, was walking along, leaving tracks, just going about its daily life. This is a record of its behavior. One of the reasons why footprints are so incredibly cool is that they happen while the critter was alive. It's not after death. This is as the animal is, walking around doing its thing. It's pretty neat. Yeah. Are you sure? Yeah, I'm pretty sure this critter is dead. The Cenomanian stage is a long time ago. There, DM Wing, I know you know that. But, yeah, Cretaceous period. Cenomanian is right here, so between 100 and 94 million years ago. So, yeah. This is equivalent in age, potentially, to the Mustn't Touch It member of the Cedar Mountain Formation, like we were talking about last Wednesday. Oh, yeah. Good stuff. And Swavoria says, how long were dinosaurs on Earth? That's a great question. Here, and this is the right time to ask that question, too, so thank you. Dinosaurs first show up during the Triassic period. And then they really take over the Earth at the beginning of the Jurassic, and they hold on to it until the end of the Cretaceous. And then you've got that pesky asteroid that hit 66 million years ago, wiped out all of the dinosaurs except for a handful of bird species, and paved the way for our own evolution. We wouldn't be here today if it hadn't been for that asteroid impact, if it hadn't been for that extinction event. But anyway, dinosaurs first evolve from their dinosauriform ancestors. probably around here, like the Ladinian stage of the Middle Triassic. We don't have fossils of the very first dinosaurs yet, but they're almost certainly from this time, or potentially even a little bit earlier. So about 240 million years ago. And they persist until 66 million years ago. So, 240 minus 66 equals about 174 million years. Dinosaurs were doing their thing. That's impressive, you know? Contrast that with we human beings, who've been around for, I don't know, between 200,000 and maybe 500,000 years as anatomically modern humans. Our own species, Homo sapiens. We've not been around for very long yet. And our hominid ancestors, proto-humans, have only been around for, I don't know, 8 million years, something like that, maybe less. So yeah. And that's wild, says Favorio. I know, right? It's fun to think about just how long dinosaurs were around and how successful they were, how incredibly successful they were. One example that I like to use is this. This should work. If any of you have ever been to Disneyland, I have vivid memories of this when I was a kid. Take a look. Some of this music is copyrighted, so I've got to do some reversing magic here to keep the VOD from getting nuked on YouTube after it goes up there. But on the Disneyland Railroad, they've got this between the Tomorrowland and Main Street USA stations. They've got this. Remember this? The Grand Canyon diorama. Man, I wish the audio were better on this. Anyway. Primeval World, dinosaurs. So there's all these lovely dioramas from, these were actually salvaged from the 1964 World's Fair. That Disney had a pavilion, the Ford Motor Pavilion. Disney produced these models for them. So it's very much like a 1960s view of dinosaurs here. We've got sauropods, we've got pterosaurs, some ornithomimids here. Here we go. And this is what I wanted to show you. This tableau here with a three-fingered Tyrannosaurus fighting a Stegosaurus here. Now this is one of those just, you know, famous mise-en-scènes. What you gotta realize is that there is more time separating these two dinosaurs than there is separating T-Rex from us. You and me and Twitch.tv are closer in time to T-Rex than T-Rex is to Stegosaurus. Think about that for a second. You know? And here, Stegosaurus died out about 145 million years ago. Minus 66. That's 79 million years. There's 79 million years separating T-Rex. Well, actually, probably like 76. Tyrannosaurus probably first evolved around 60... I don't know, 68 million years ago, something like that. So, here. 145 minus, let's say, 68. 77 million years. There's 77 million years separating those two dinosaurs. There's only 66 million years separating T-Rex from us. Think about that. You know? Yeah. So yeah, I think a lot of people don't really realize the extent of the Mesozoic era. The age of dinosaurs, as some people call it. It's a long time. It's a long time. We're used to thinking of, many members of the public are used to thinking of dinosaurs all kind of having lived at the same time. You know, oh, in the prehistoric time. Shoot, one of these isn't even a dinosaur. There's a Dimetrodon right there. It's this guy. But yeah. Here is a diagram of dinosaurs in Utah. 27 sequential fauna levels at least. 27 different sections of time in which the dinosaurs are different. Dinosaurs were around for like over 170 million years, and that cast of characters is just consistently, constantly changing all the time. You've got new species evolving, you've got species going extinct, you've got faunal turnover events where you've got catastrophes that occur and then you lose entire groups of dinosaurs sometimes. It's this great dynasty like this. And we're just kind of starting to figure out the details here. Over the past few decades. Here in Utah, for instance, this chart is from... There were what, like, maybe 20 dinosaurs that were known? In, like, let's say 1990. There were, like, 20 genera and species of dinosaurs known from Utah. Maybe. Now we've got more than 115. And by paying very, very careful attention to the strata, figuring out when these different critters lived, we can build a chart like this and start to figure out who lived when and what's going on in these ancient environments to cause these changes. We really are living in like the golden age of dinosaur paleontology right now. It's like Jim Kirkland always says, these are the good old days, right now. So it's an exciting time to be a paleontologist for sure. Vexday says, do you have any advice on removing brachiopods from limestone? Vexday, I would say do it carefully. It's been a long time since I prepped any invert fossils. Do you have an air scribe? If you've got the budget for it, that could be a really excellent tool to have. It's, you know, standard for fossil prep. You probably know about this already. But yeah. Yeah. Anyway. Anyhow. Suavorio says, I was watching a documentary and I had those two fighting as well. I need good documentary recommendations. Stegosaurus did fight with dinosaurs like Allosaurus. They lived at the same time, same place. We've got evidence that they actually fought. Healed injuries on both of these guys, presumably from their counterpart, that show that these interacted and fought in life. So yeah. Yeah. said it was a three-fingered T-Rex. It's supposed to be T-Rex, DM Wing. It's... yeah. Tyrannosaurus has 2 fingers, Allosaurus has 3, but they're pretty clear it's supposed to be Tyrannosaurus. Here.
Come on, look pretty. That's it. Put the head right up there. That's it. Here. Hello, I'm Walt Disney.
Hi, Walt Disney.
These little creatures are baby dinosaurs. We're bringing them back to life for...
Where is that? Would it be... that's Sinclair Dino Land. Is it here?
Man. Homo
Triceratops. Here we go.
Behold the most fearsome reptile ever known, Tyrannosaurus rex, king of
See?
the dinosaurs, threatening mortal combat with an armor-backed Stegosaurus in the classic struggle for survival.
Wait. He's got more than 3 fingers there. 1, 2, 3, 4. Anyway, yeah. Not even a dinosaur then? No, there are dinosaurs with 4 fingers. Ceratosaurus. And some of its skin had 4 fingers. There we go. There's some dinosaurs that had 5 fingers on each hand. But never more than that. Anyway, and then you've got dinosaurs that have got 1. Or at least ostensibly 1 finger, like Mononychus, whose name means 1 claw. Yeah. Anywho, point is, dinosaurs were around for a long time. They had a whole host of different morphologies, different ecologies, different stuff that they're doing. They're just a fascinating group of animals, you know? Yeah. So yeah. Yeah. And no panda stumps, not that we know of yet, damn wing, no. There were critters that had more than 5 fingers way back in the day. Critters like Ichthyostega, which is, you can think of it almost as like a descendant of Tiktaalik. So it's a fishapod. So it's like, it's a transition between lobe-finned fishes and tetrapods, land-living vertebrates with limbs. Things like amphibians, reptiles, mammals. And Ichthyostega, I think, has 8 fingers on each hand? Or is it 7? 1, 2, 3, 4, 5, 6. Maybe 6 on the hands and then 7 or 8 on the feet? I'm not sure. One, 2, 3, 4, 5, 6, 7, 8. There we go. That is on the hand. The descendants of these guys reduced their digit count to 5, and we've been working with that ever since. Like, we are descendants of a critter like this, and we've still got 5 fingers. So at one point, that just kind of became... I was going to say that became the standard, but that's not a very helpful way for thinking about it. It's easier to lose digits than it is to evolve new ones. That's why the 6th finger of a panda, its thumb, is not actually a finger, it's a wrist bone. Anyway, it's easier to lose digits, way easier to lose digits through evolution than it is to evolve new ones. And so, at some point, the descendants of these guys reduced it down to 5, and that's been what we've been working with ever since. Some dinosaurs reduce it further than that, though. Yeah. Anyway. Yeah, 5 became the norm, and some, like horses, reduced that down to just 1. That is true, Charlie's Dragon. And there are some critters who reduce it down to none. Like this one right here. No fingers at all anymore on these guys. Yeah, pretty cool. Oh, I know, right, Lenina? Very cute. Snakes get a bad rap, just like sharks. So I like to show cute pictures of snakes. Yeah. Snakes are so cool. Anywho. It's fun to talk about this kind of thing, you know? The history of life on Earth is really interesting. There's so much to learn. There's so much to marvel over. So much to talk about, you know? So I'm really pleased that we've got 270 people watching right now. This is it's a privilege to be able to share this stuff with you. Why don't we get into another piece of fossil news here, also regarding dinosaur footprints. This is pretty exciting stuff. Microraptor. This little, like, dromaeosaurid dinosaur, member of the same family as Velociraptor. Hence the raptor in its name, I suppose. There we go. For a long time, we've kind of wondered what's going on with these guys. They've got these feathers extending off of their legs as well as their arms. There's this idea that maybe they were gliders, like this, almost like a flying squirrel or something. Jumping from a tree and then kind of gliding down to the ground to pounce on prey, something like that. Like you see right here. But now, we've got evidence that maybe they were doing something different. This 100 million year old Microraptor flapped its arms while running. Learn how a species with shockingly long strides might have used its arms for a unique form of flight-like movement. Interesting stuff. So about 100 million years ago, a sparrow-sized Microraptorian, long-lost cousin of modern birds, sped across the landscape of modern-day South Korea, leaving behind a mysterious set of footprints with surprisingly long strides. So big space in between these footprints. What in the world? What's going on? Now paleontologists suggest that the species used a unique style of aerial motion, flap running. Published in the study in the journal PNAS in October, the findings may improve our understandings of the origins of flight. There it is there. I'm surprised we didn't go over this at the time. I must have been getting ready for SVP. It only had 2 toes on each foot, which these guys did. Well, 2 toes that would have been contacting the ground. As a dromaeosaur, you've got the digit 2 claw is suspended above, and then the digit 1 claw is the hallux behind. So like that, remember in Jurassic Park? This image is probably burned into several people's minds here. There we go. There we go. See? So, 2 toes on the ground. So we've got digit 1, digit 2, 3, and then 4 is behind it. Only 2 of those are actually contacting the ground. This digit right here, that hypertrophied digit 2 claw, is it doesn't really contact the ground. That wouldn't have really shown up in a footprint there. So there we go. Here's a good example of that. Dromaeosaur tracks from Colorado. So just 2 toes in the footprint there. Sometimes you've got like a hint of a 3rd toe there, but not really. Not usually. Yeah. Does that make sense? It had 2 toes on each foot, and that's what told us it was a raptor dinosaur, a dromaeosaur. Says Thomas Holtz, carnivorous dinosaur specialist at University of Maryland, and a co-author on the study. All the Jurassic Park fans know raptors walked on 2 toes, and their killing claw was lifted off the ground and didn't make a toe print when they were walking. But what was curious about this trackway was the distance between the footfalls. Normally, scientists calculate the strides of the speed of a fossil animal using the animal's hip height and the distance between the animal's footprints. So there's actually like a calculation that you can do about this. I've got that in a book over here. Here we go. I think we've got it in here. Talking about dinosaur tracks and calculating speed based on footprints like that. Let's see. There we go. Speed estimates from dinosaur footprints. Here we go. Dinosaur speed can be estimated from footprints using a method developed by British researcher R. McNeill Alexander. Here's how it's done. A stride is the distance from one point on a footprint to the same point on the next print of the same foot. When dinosaurs walked, they took strides. When dinosaurs ran, they took longer strides. Anyway, so you take the length of the stride in meters and divide it by the leg length in meters to get your relative stride. Then you can run this calculation here. So actual speed in meters per second divided by the leg length in meters times the gravitational acceleration in meters per second squared. The square root of that is your dimensionless speed there. So there we go. Actual speed is dimensionless speed divided by the square root of leg length times gravitational acceleration. I know that's a lot of math, but it's simpler than you might imagine. You know? Yeah. Isolated says, was the rear dew claw used for anything for the raptors? Probably not. It has been suggested it may have helped them perch on things like tree limbs, but I wonder about that, you know? Yeah. Yeah, it may have just been vestigial. Anywho. Normally, scientists calculate the speed of a fossil animal using the animal's hip height and the distance between the animal's footprints. In the case of the Microraptorian fossil, however, the speed calculated with these parameters was phenomenally and unrealistically fast. If we scaled it up to the size of a larger animal, it would run much faster than a cheetah or a pronghorn, Holtz laughs. In fact, it was an ordinary run. So, it seems like this animal is going ridiculously fast. You know, unsafe speeds. But no, that's just because there's something else going on. The research team considered other possibilities. Maybe there were tracks missing. Maybe the raptor had stilt-like legs, akin to a Dr. Seuss character. Or perhaps there was some form of aerial locomotion going on. The latter possibility, aerial locomotion, seemed like the most likely, specifically because small-bodied raptors are known to paleontologists for their long arms, their long arm, leg, and tail feathers. Delicate features preserved in ancient lake deposits in China. We've got lots of examples of this. Zhen Yuanlong is a good example. It's a dromaeosaur, a member of this family, with feathers preserved on its arms, and on its tail, and on the rest of its body there, too. I think it would have looked something like this. Lovely art by Gabriela Guetta there. The team's consensus now is that we're seeing an animal that's suspended in the air between these footprints, Holtz explains. And so, technically speaking, it's not a true run, and that's the reason why the math wasn't working out properly. So it's not really running. It's probably taking some steps and flapping, and then taking some more steps. So it's kind of like flap, leaping, running. The old flap and run, says Gregory. Yeah, there you go. How are you doing, Gregory? Good to see you. Yeah. Pretty cool. So, it's not a true run, it's a flap run, which is exactly what it sounds like. The Microraptorian might have ran while flapping its feathered arms to achieve some lift, which would have given it greater speed. Ever since we discovered that Microraptor and its cousins had wings, researchers have suspected that they had some aerial locomotion, including possibly powered flight, Holtz says. In fact, the study authors speculated that the tracks in question could have preserved the moment a Microraptorian landed or accelerated to takeoff. The question of flight, however, led to a contentious development within the paleontology community. Did Microraptorians and birds inherit aerial locomotion from a flying common ancestor? Or did they develop their aerial locomotion independently? This is one of those questions that keeps me up at night sometimes. When we're trying to figure out the evolution of birds from dinosaurs, the standard image is usually like this. You know, this is the classic Mark Hallett illustration. We've got a little, like, troodontid type dinosaur here, back in the middle Jurassic, maybe. And then they start to develop feathers like this, the arms get longer, and then you get something like Archaeopteryx, and then finally you get to your modern birds. Something like this certainly is how it happened to a certain extent. We know that birds evolved from a dinosaur like this, but this is almost misleading in how direct it is. They're only showing one lineage here. There would have been all kinds of other evolutionary experiments coming off of this, all kinds of other branches that maybe didn't really go anywhere. It is a lovely illustration, Charlie's Dragon. It really is. But it almost kind of reminds me of Zallinger's March of Progress. You know, this grossly oversimplified to the point of being misleading illustration, you know? There are all kinds of other interesting things going on here. It's not a simple progression from Dryopithecus to Homo sapiens. There's all kinds of weird branches coming off, different experiments, critters moving, and, you know, this way oversimplifies it. It's cherry picking just, you know, the line that leads to modern humans, and it's not even like showing all of the weirdness that happened in between there, you know? It's too neat, too pretty, too clean. And in a sense, this is too. There are a bunch of different very bird-like dinosaurs that have got very bird-like traits that are not on the direct line to birds. You've got dinosaurs that are developing a Pyga style. You know? That like nubbin where the tail vertebrae fuse up so that you can get this big feather fan on the end of the tail. Nomingia does this, an Oviraptorosaur. You've got dinosaurs that go off in weird directions and do other stuff like E.G. and the other Scansoriopterigids. These guys are incredibly bizarre. They've got a wing membrane that's made of skin. Despite the fact that these guys had feathers, they developed these really weird membranous wings, almost like a bat or like a pterosaur, you know? Like dragons, Alexander Morrison. These are real dragons in a sense. Yeah. So there's all kinds of weird stuff going on. So that brings us to that question that keeps me up at night sometimes. It doesn't literally keep me up at night, but I think about it a lot. It's... Did some of these very bird-like dinosaurs, do they look so bird-like because they are descendants of the first bird? When we look at dromaeosaurs, these guys, the family that Velociraptor belongs to, Velociraptor, Deinonychus, Utahraptor, Microraptor, etc. These guys have got feathery wings, despite not being able to fly, we think. Maybe Microraptor could fly. We know these guys are very close to the origin of birds. These are some of the most bird-like dinosaurs. Is it that birds evolved from a dinosaur like this, or did these guys evolve from the first bird? Basically, you've got bird-like dinosaurs evolving into the first birds, and then birds continue on and do their thing, and then these guys here could be a side branch that come off from the first birds. You know? This kind of also, it gets into a core concept in paleontology, the idea of phylogeny, evolutionary family trees, how we classify living things. When I say the word bird in this context, birds are, in order to be a true bird, you have to be on the line that goes to our modern birds, part of that lineage, you know? You are a bird if you're part of that clade, you know? So a clade is an evolutionary group that includes the ancestor and all of its descendants. So let's see, here's a primate one right here. There we go. So, primates here, all descended from a common ancestor. So let's think about this in terms of birds. Imagine that all these are birds up here. All the birds descended from a common ancestor. That's why they're birds. That's why they're a true evolutionary group. As you can trace all of their ancestors back to one ancestor at the beginning. If you had multiple different ancestries for birds, they wouldn't be a true evolutionary group. Kind of like how, let's see, let me think. What would be a good example of this? Trees are like that. Tree is not a phylogenetic group. You know, you've got trees like oaks that are totally different from pine trees. You know, they've got different ancestries. So a tree is not a true phylogenetic group. Ironically enough, because we're talking about phylogenetic trees, but don't get confused, sorry. Could it be that when we're looking at here we go. That when we're looking at birds like this, modern birds, it could be that these guys, including the dromaeosaurs, actually evolved off of that branch. That they would be true birds if they're descended from an avian ancestor. If the same ancestor that gave rise to all of the birds also gave rise to dromaeosaurs, that would make them birds too. Does that make sense? And maybe that's why these guys could fly around, you know? So did Microraptorians and birds inherit aerial locomotion from a flying common ancestor? Or did they develop their aerial locomotion independently? If they did inherit it, aerial locomotion from a flying common ancestor, that would kind of imply that dromaeosaurs very well might be true birds, which would be wild, right? Yeah. So yeah. Anywho. And have the traits associated with that clade, like a pygostyle and all the other. Exactly, Charlie's Dragon, yeah. There you go, DM Wing, yeah. And wouldn't that be cool, Alexander Morrison? Yeah. So anyway, we got back to the article. Let's continue. Isolated says, do you think we will ever get a true answer to that question? Yeah, I think someday we will. What we need is better fossils of critters like, here. Better fossils of critters like this and its ancestors. Here.
This is Anchiornis. She's a small, feathered dinosaur.
This is, right now, at present, probably the closest non-bird dinosaur to true birds that we have right now. You might get different answers if you talk to different paleontologists who study the origin of birds, but this would probably be your most common answer.
Take the phone to Mommy now!
Gameverse Man? Who is it?
It's the dinosaur man!
Okay.
Laughing face.
Gameverse Man, thank you for the 2 months of support. Really appreciate you. At tier 2, by the way. Ding, 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 ding. Thank you for that. Good stuff. Anyway, want to know the ichnotaxon of this Microraptor-ish tripod? They might not have named it yet, Germstrom. Yeah, we'll take a look in the paper. And Royman says, have you been to the Oakland Zoo Glowfari event? It's dinosaur themed this year. It was a couple years ago, too. I've not been so far this year. I should talk to them about bringing Velia and getting paid to do that. That would be cool. But anyway, yeah. Anchiornis might be the closest non-bird dinosaur that we have to birds right now, although it might also just be a true bird if its ancestors were birds.
For hunting
you know?
insects.
Uh-oh. Here comes the Sign Raptor. This is from the
Anchiornis is slow and
Netflix show Life on Our Planet. It's good stuff. It's a little corny at times, but I'm really glad it exists. I think it's a wonderful bit of public outreach, you know?
The Sign Raptor has her cornered.
You probably know what's coming.
Anchiornis has run here for a reason. She can fly.
They felt like an afterthought in this series?
One small step.
They're the focus of the series. How could that be the case?
For life on Earth.
I don't know if I understand where you're coming from there, Deathsaurus.
With these early gliders, a new dynasty was born.
Yeah. So
And
glider, but
it was flight that would help their descendants stay alive in the era after the asteroid.
True. Yeah, to a certain extent. Yeah. So Anchiornis is from the Jurassic. It's from before Microraptor. But anyway, I hope that's still instructive. Yeah, did Microraptorians and birds inherit aerial locomotion from a flying common ancestor, or did they develop their aerial locomotion independently? Even if the former one day proves to be true, these guys inherited flight along with birds from a common ancestor. It doesn't necessarily negate the flap-running theory. The species in the study may have evolved away from flight while retaining some features like an ostrich. In the case of the latter, however, Microraptorians could have had some of the mechanics that evolved into flight in its descendants. This could give us clues about the basic equipment that the ancestors of birds may have also had, Holt says. It's an interesting idea. How many times did flight actually evolve? You know? If dromaeosaurs and birds... If dromaeosaurs evolved from birds, that implies that flight only evolved once. But if flight evolved a bunch of times, if it's not that difficult for dinosaurs to evolve flight, then, well then, A, that's a cool idea in and of itself. Flight is a super, super rare thing to evolve. True powered flight? This controversy aside, there's a generally accepted, consensus, it's an awkward sentence there, that flight only ever evolved 4 times over the history of life on Earth. Insects, pterosaurs, birds, and bats would be the 4 times. But if birds evolved flight, and if dromaeosaurs evolved flight, and Scansoriopterigids evolved flight, then that would be 3 times just within Dinosauria. You know? That'd be pretty nuts. So yeah. And Charlie's Dragon says dinosaurs not that far from flying could have split into multiple lineages that evolved flight. Yeah, that's definitely another possibility, Charlie's Dragon. Yeah, yeah. That if your ancestors have all got if they've got all the basic building blocks of flight, feathers, hollow bones, elevated metabolism, proper like skeletal anatomy for muscle attachment for the flight stroke and all that. And you've just got multiple different lineages springing off of there and each evolving flight independently. You know, that's definitely a possibility. Which would be unusual. Because in mammals have only ever evolved flight once. Bats. That's one lineage. Presumably they all evolved from one single species. All bats came from one single species. That's why they're all related to each other. Pterosaurs, presumably it's the same way. They all come from one common ancestor. Dinosaurs would be the odd exception there, where you've got flight evolving multiple times in different lineages. It becomes easier if they're all very close to related lineages. If they're all Maniraptoran dinosaurs that all have got those same basic building blocks for flight, but then you have flight springing up here and here and here and here in different species. I don't know. It's interesting to think about. Yeah. Brachydactylus says, while rare, it does convey a lot of potential survival advantages to move across 3 dimensions, talking about flight, while so many of your predators and potential prey struggle with 2. Yeah. 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 It's more likely than that, too. Lost and reacquired in multiple lineages of theropods. Usually when things are lost, they're not reacquired, though. Like, I can't think of a single instance in which a lineage of living things has lost the ability to fly and then regained it. There's an idea that we have in the study of evolution called Dollo's Law. Dollo's Law of Irreversibility. Basically, an organism never returns exactly to a former state, even if it finds itself placed in conditions of existence identical to those in which it has previously lived. It always keeps some trace of the intermediate stages through which it has passed. So, like, if you lose the ability to fly, you're not going to re-evolve it. Yeah, and we see this in flightless birds. We see this in insects that have lost the ability to fly. They don't re-evolve it. Flight might be such a rare thing to evolve in the first place. You've got to have so many different things that all happen exactly right to set you up perfectly to be able to evolve the ability to fly, that it's not likely at all to evolve again. But maybe dinosaurs are an exception to that. Who knows? Yeah. Hustle Tree says, what is the theory behind that? Seems suboptimal. It's more of an observation. You know? Yeah. So Dawkins says the law is really just a statement about the statistical improbability of following exactly the same evolutionary trajectory, or indeed any particular trajectory, in either direction. And Gould said, for example, once you adopt the ordinary body plan of a reptile, hundreds of options are forever closed, and future possibilities must unfold within the limits of inherited design. That's a good way to put it. Yeah. A lot of this has to do with, like, developmental biology. It's like when we were talking about number of fingers, we were talking about ichthyostega there earlier in today's stream. Where originally these guys had 7 or 8 fingers on each hand, and then they reduced it down to 5, and we've had 5 ever since. Nobody's, growing extra fingers and then having that be passed on to their descendants. It's just not happening, Those mutations are not selected for. It just doesn't work anymore. And even if you are going to evolve an extra finger, it's not a true finger, Like pandas with their thumbs. The thumb of a panda is not a thumb. It's an extra wrist bone sticking out of the side. It's a carpal bone.
I can see that my 50,000 a year has been well spent.
Miss Capri Kell, thank you for the 8 months of support at Tier 3. Really appreciate that, Miss Capri. Thank you. Appreciate you keeping me here on the air the past 8 months. Thank you. Anyway, there we go. Yeah, the panda's thumb is not a thumb at all. It's an extra wrist bone. It's not even so it's not a digit. They still have 5 fingers. But their thumb is not actually a thumb. Does that make sense? Yeah. So it's just really, really improbable that you would re-evolve something as complicated as flight after having lost it in the first place. It was a total fluke that it evolved at all at the beginning. For that to happen a second time is almost seems impossible. Unless you've got multiple different lineages who've all got those same basic building blocks for flight, like you had with these Maniraptoran dinosaurs. So yeah, I don't know. It's interesting to think about. Hey HD, how you doing? Hello. Yeah. And Ms. Yvette says, and they are extinct. Do you think evolving not being able to fly can make you go extinct? In the case of birds, yes. Yeah, when we were looking at all of these different bird species on different islands that have gone extinct because of humans arriving there within the past few thousand years. Some of them, like the dodo, were recent enough to be in recorded history. Dodo right there on the island of Mauritius. You've got elephant birds in Madagascar. You've got flightless rails off the coast of Africa right there. You've got all of these other flightless bird species. Birds, when a new island forms, sometimes you have birds that show up there. They fly to that island, maybe they get carried there by a storm or something. And they're flying birds, but they get stuck on this island. They can't get off, but they can make a good living there. And since there's no predators, it's a new island, they lose the ability to fly. Flight is a very expensive, very constraining kind of thing. In order to be able to fly, you've got to have a ton of energy that you devote to it. You've got to have really lightweight body. You've got to be oftentimes really small. It's easier to take off the smaller you are. Take off from the ground. It's easier to fly the smaller you are. And so if birds don't have to fly anymore, if they're just fat and happy on these little islands, they can get bigger and bigger, and they can devote more of their energy to laying more eggs rather than to flying. And so it can be a winning strategy to get bigger and to lose the ability to fly if you don't have any predators. If there's nothing to escape from, get rid of the ability to fly. But then once predators show up, predators like humans, and the critters that humans bring with them, rats and dogs and pigs and cats, well, suddenly you can't fly anymore. And what was a really, really good strategy before people showed up to wreck everything, suddenly that strategy doesn't work anymore, and you're extinct before you know it. That's what's happened with so many different species of flightless birds, especially on islands, over the course of human history, just within the last few thousand years, you know? So yeah. Yeah. Does that make sense? Yeah. And Charlie's Dragon, yeah, there you go. There's an island rail that evolved twice, sort of, yeah. Yeah. It's more the same thing happened twice rather than the same species. They're not the same species, but yeah. An island had a species of rail, it went extinct, thanks humans. And a flying rail from a nearby island flew over and became flightless. Yes. Yeah. The Aldabra rail. Yes, indeed. Yeah. Interesting stuff. So yeah. Yeah. Aldabra, yeah, like the Aldabra tortoise. Same place name, I presume. Bird that came back from the dead by evolving twice. This should have quotation marks around it. Because you had the same parent species develop flightlessness twice upon ending up on the island on 2 separate occasions. But yeah. Pretty neat. Anywho. And it sounds like magic? It's not. It's just you've got... There are certain features that evolve again and again over the course of the history of life on Earth. And some of them are kind of, like gross anatomical features. Not gross like ew, gross. Not gross like, oh, sorry, wrong button. Not gross like, but gross like, easily recognizable. Gross anatomy is like stuff you could just eyeball it. Like, oh yeah. Not tiny and precise, but like, small and gross, Like gross income. Same word there. You've got like saber teeth are one of these things that evolve again and again and again within synapsids. Mammals and their kin. You've got it in Gorgonopsians and Cynodonts. You've got it in, oh yeah, there's... Yeah, saber teeth on, is that Inostrancevia? Yeah. You get it in the, Nimravids. So this is a group of what look like cats, but they're not actually cats. They're a different kind of carnivorous mammal. That looks to a crazy extent like a Smilodon skull, to me, to my non-mammal paleontologist eyes. You've got Smilodon and the other Machairodonts like this. Another time that saber fangs have evolved independently. You get it in these kind of marsupial type guys, these stem marsupials. These guys evolved from the same ancestors that marsupials did. Not related closely to the saber-toothed cats at all. This critter's more closely related to an opossum or a kangaroo. Yeah, so these are all carnivorous animals that evolve these hypertrophied canine teeth, these huge fangs, independently. Convergent evolution. So sometimes you get this sort of thing that evolves again and again like this, if it's just a trait that works well for this group. And part of that is, I think, due to the constraints of, like, the body plan. So mammals like this, when you've got a carnivorous mammal, oftentimes they look like this. They've got 4 legs. So whether you're, you know, a marsupial type critter like this, or whether you're a true cat like Smilodon, or whether you're a Nimravid like this, a cat-like non-cat mammal, or whether you're a Gorgonopsian like this, there's that same basic body plan. You know? You've got 4 legs, you've got a short tail, you've got a big chunky head. It behooves you to develop big fangs like that. Part of this is going to be, it's just kind of in the basic blueprint of their DNA. This is what they're working with. They've got the building blocks already there. And so this is an easy form to evolve again and again. Yeah. Convergent evolution. Developing similar traits like that in unrelated groups is easier if the groups are slightly closer to each other, you know? It's going to be easier to evolve saber fangs between a Nimravid and a true saber-toothed cat than it would be to evolve saber fangs on, I don't know, a stick insect or an oak tree, you know? You see what I mean? The more similar the body plan is already, and often like the more closely related they are, the easier it is to evolve very similar characteristics. Because you've still got those same basic building blocks there. Like, you've got enough of the same DNA that, like, there's enough material for evolution to kind of work with where it can yield similar traits like that. Does that make sense? Yeah. Yeah. It's Suki and Overlords. There you go, Alexander Merson. Yeah. Yeah. And Charlie's Dragon says, yeah, to a certain extent, they already had bigger canine teeth, so it's easier to just make them even bigger. Yeah. Whereas something like an oak tree, well, it's got no teeth at all. Where are you even gonna, how's that gonna work? You know? It's not gonna happen. But if you've already got teeth, and you've already got canines that are a little bit larger than the rest of your teeth, and they're already conical like that, that's good grist for the mill of evolution, you know? It can work with that. Natural selection can take those features and run with them, so to speak. Kind of anthropomorphizing here, but yeah. And HD says, isn't there a deer with fangs? And there is even a saber-toothed kangaroo? Kind of, yeah. Yeah, so there are, what is it, chevrotains? Yeah. Chevrotin. Yeah, they're pretty cool little guys. And they love swimming. Yeah, also known as mouse deer. But yeah. there's a number of plant-eating ungulates like this, hoofed mammals, that develop those hypertrophied canines like that. Yeah. Warthogs famously have got really big canine teeth too. Yeah. And path dependency. I like that, Smay. Yeah. Is that a concept in a different field? I'm not familiar with that term, but it sounds like it. Yeah. And Extort says, what about ostriches and old terror birds? Were they trapped on an island? And were they ever really birds? Oh, no, they're definitely birds. Every animal that evolved from a bird ancestor is a bird. You know? By definition. You don't have to fly to be a bird. You know? Penguins don't fly, they're birds. Ostriches are birds, they don't fly. The flightless cormorants of the Galapagos are birds. They arrived on the Galapagos Islands at one point, and their wings just, since they didn't need them anymore to escape from predators, or to really get around that much, since the islands are pretty small, just got rid of them, you know? Or they didn't get rid of their wings, but they reduced them to the point where they can't fly anymore. And it's worked really well for them. You know, they're still around. So yeah. But as for ostriches losing the ability to fly, at some point, they must have just been selected for large size rather than for flight. And it was like their ancestors that could fly couldn't get as big. And getting big was the key to survival at some point. And so they just got bigger and bigger and developed longer and stronger legs for running fast. And, you know, now they're stuck on that path, you know? There probably used to be lots and lots and lots of species of big flightless birds running around. In fact, we know that there were in New Zealand and Madagascar, moas and elephant birds, respectively. But yeah. Sometimes you kind of paint yourself into a corner evolutionarily. That's what happened with ostriches, where they, for whatever reason, it was important to be big, and it wasn't important to fly, and now they're stuck there. They're stuck on that path. And they can't go back. You're not going to have ostriches developing the ability to fly. It's just not going to happen. You know? Their descendants, hopefully there will be descendants of ostriches millions of years into the future. Hopefully we don't drive them into extinction as humans are so enthusiastic about doing sometimes. Hopefully, if ostriches exist, if their descendants survive millions of years into the future, we'll have lots of other species of cool flightless birds. None of them are going to evolve the ability to fly again. You know, they're done with that. So yeah. And Terminator Pig says, I wonder what we've locked ourselves out of through evolution. That's a great question, Terminator Pig. We as human beings... Well, egg laying is probably one of those. The ability to lay hard-shelled eggs. Our ancestors did it. Yeah. Things like cynodonts back in the Triassic period. These guys laid eggs. I'll show you a clip from Walking with Dinosaurs here.
The Placeria.
Alright. Here, looking for that particular clip with the cynodonts laying their eggs. These are like mammal ancestors. Ancestors of true mammals, I should say. Here we go. There we go. Oh, here comes Coelophysis. That's not even the part I was looking for. I was looking for the part with the eggs. And it looks like they're somehow missing part 3, which must be the part that's got it. Anyway, those guys laid eggs. And thank you, Bumsy Bear, for the 2 months of support. Appreciate you. Thank you. Thank you for keeping me here online. Here we go. So this is a mammal from the Mesozoic.
Adalatherium. She's less than 2 feet long, but even so, she's still one of the
biggest mammal of the
mammals that
Mesozoic.
have yet evolved. She spends most of her waking hours searching for food. At the end of this tunnel, there are eggs. Potentially a rich source of protein.
Yeah, don't eat those eggs, though. Those are your eggs, mama mammal.
But she doesn't eat this particular clutch. These are her own eggs. And this...
Yep. And we do still have egg-laying mammals today, like the echidna and the platypus. Famously, those monotremes are egg-laying mammals. If we trace our ancestors as humans back far enough, we will get to egg-laying mammals back in the Mesozoic. The ancestors of the Therian mammals, Therians are placental and marsupial mammals together, their ancestors laid eggs. That's something that we've evolved out of. And our descendants, you know, if we have descendants, if human beings don't go extinct, if we ever do have other species that evolve from us, they will never evolve egg-laying again. No Therian mammals ever will. No descendants of marsupials or placental mammals will ever evolve egg-laying again, I don't think. It's just one of those things that's like irreversible, you know? We're on this path, there's no going back, you know? Giving birth to live young is what we do. So yeah. Anyhow. And Crimson Carnotaurus says, imagine a human having to lay eggs after seeing what birds go through. It wouldn't be pretty. I don't know if human birth is particularly pretty by comparison. I think laying eggs would be a lot easier, you know? Just pop out some little ping pong balls instead of like a small human? Like, oh boy, you know? It's so much easier to just squirt out some eggs. Yeah. Anyway. Imagine that, but with kiwi dimensions. Well, kiwis are nuts in their dimensions. The eggs that they produce are... Yeah. But again, that's one of those things... It's probably like kiwis' large size is one of their keys to their survival. And that's why they lay such big eggs, is so that their babies are born large. They're more likely to survive. Anywho. But yeah. And there you go, Spalvorio. Yeah, I know, right? Anywho. Oh, where was I going with this? Shoot. Oh, Suavorio, thank you. Suavorio had a wonderful question here that I think is really relevant. Did Tiktaalik, this fishapod, this critter which is often considered like a transition between lobe-finned fishes and tetrapods, did this critter lay hard-shelled eggs? The answer is no. These guys almost certainly, I would say certainly, laid soft, jelly-like eggs in the water. Kind of like salmon do. Maybe salmon are not a good example, but yeah. When did critters start laying hard-shelled eggs on land? That's a really important time in evolution.
Live young. They're just used in different ways.
Here we go. So, I hate the animations in this particular video, but it is a good video though. We'll excuse how non-optimal the creature designs are in this. There we go.
Would you believe that walruses, rattlesnakes, and parakeets all once lived in the same house?
No, but they're all amniotes. Here.
Let's go back about 350 million years. Look around.
House is an
Steamy
analogy there.
swamps and rainforests of horsetails and ferns cover the region. Amphibians are the dominant land vertebrates. They range in size from newts to crocodiles, and all require water to do their egg laying.
So those are critters that would be like, critters like Ichthyostega. Critters like this. This is basically what we're looking at here. These kind of fishy-looking, amphibian-y type guys. Descendants of something like Tiktaalik. Something like this.
If they don't go to the water, their shell-less, jelly-like eggs will dry out.
Yep.
Because of this hazard, they spend most of their time living in or near fresh water. That is, until a breakthrough in evolution changes everything.
Yep, the amniotic egg.
The amniotic egg is shelled, waterproof, and can be laid on dry land.
So this is, hate these animations. Terrible. Why make it all cutesy like this? It's not that much more effort at all to actually make it accurate. Anyway, legs are bending the wrong way. This was extremely important. It allowed tetrapods to conquer the land. They weren't tied to the water anymore. They could venture far inland. They didn't have to lay their eggs in a swamp anymore.
It is produced by the amniotes, a new group of animals named after their revolutionary egg.
Yep.
The first amniote is a tetrapod, a four-legged animal, resembling a small lizard.
So it would have looked a lot like this, like Hylonomus, something like that. Took a look at this guy on, I think it came up on Thursday, didn't it? Hylonomus right here. Looks like a lizard. It is not a lizard. It is not a lizard. Not a lizard. Lizards wouldn't evolve for like a long time after this. Maybe like 100 million years. 200 million years, something like that. Hylonomus. Extinct genus of reptile. It is the earliest known crown group amniote and the oldest known unquestionable reptile. Despite being amongst the oldest known reptiles, it's not the most primitive member of the group. Anyway, you also get Archaeothyrus? There we go. The first mammal, or first mammal line critter. Hylonomus and Archaeothyrus, there's the split. Just as soon as critters start laying hard-shelled eggs on land, you have the split that occurs right then between mammals and reptiles. Yeah. All basal reptiles are lizards. Don't say that, DM Wing. I know you're being facetious, but other people in the chat don't know that. Yeah. So this is the basal amniote body form. Exactly, Alexander Morrison. Exactly. Yeah. So, first mammal right here, or first critter on the mammal side of the tree of life? First reptile. They look really similar, right? And of course they're going to look similar because they both came from the same species. These are both descendants of the same species. And so of course they're going to look similar. They're not going to instantly be totally different. They're both coming from the same place. So they're going to look real darn similar to one another. You know? Does that make sense? Back then, all of the amniotes looked like a little lizardy type thing. Does that make sense? Yeah.
While some amphibians can walk around on land and bury their eggs in wet soil or highly humid areas, nothing before the amniotes has the ability to lay its eggs on completely dry land. Because of this evolved egg, the amniotes are the first animals with the ability to live a fully terrestrial life. But despite their move inland, the amniotes have not abandoned their pond-dwelling upbringing. In fact, the amniotic egg brings the pond with them by enclosing the aquatic environment within its shell.
We're just going to listen to the narration.
By four main upgrades that are unique to amniotic eggs.
Oh, here we
Let's
go.
take a closer look. The first development is the most obvious.
The shell.
Egg's protective shell. It's tough but flexible and has a leathery surface still seen in some reptile eggs today. The shell protects the eggs from predators, bacteria, damage, and drying out. But unlike the walls of a fish tank, the shell of the amniotic egg is porous, allowing oxygen to pass through so that the growing amniote inside doesn't suffocate. The next two developments are two separate membranes that work together like a pair of lungs.
Amnion and chorion,
They bring
right?
oxygen into the embryo while removing carbon dioxide. The first is the chorion, which is the protective layer that oxygen passes through after entering the shell's tiny pores. You may recognize the chorion as the thin skin you peel away on a hard-boiled egg. Think of this waterproof membrane as the in and outdoors of the egg. It's the entrance for oxygen and exit for carbon dioxide. The membrane working with the chorion is the allantois.
Oh,
If the
allantois,
chorion
sorry.
is the doors, then the allantois is
amnion
essentially
is
the
inside.
lobby of the building.
Anywho, you get the idea. The point is the amniotic egg was really, really important. That's what allowed amniotes to take off. And when I say amniotes, let me show you what I mean. Let's go to our tree of life here. Let's jump to humans first, just to get our bearings here. Let's start off with what we're comfortable with what we know. We know ourselves. Humans are right here. We are a kind of mammal. Let's zoom out to mammals here. There's mammals, which include everything from humans to elephants, hedgehogs, hares, echidnas, lemurs, bats, rats, cats, wombats. Are all mammals. So mammals, Mammalia, aka Synapsida, and Sauropsids, aka reptiles, both of these branches together share a common ancestor. They are both amniotes. The amniotes is the group that includes mammals and reptiles. Amniotes. And each one of these, ancestrally, has got that hard-shelled egg. That key innovation that allowed the conquering of the land, you know? Does that make sense? Yeah. Finally a senior in high school. Well, congrats, Raven. Congrats. I hope you're having... I hope this is all making sense, and I hope you're having fun. So anyway, that amniotic egg was really, really important. Yeah. Early sauropsids. So the earliest of the reptiles and the earliest of the mammals looked the same, basically. Because they both came from the same ancestor. They were the same, and then they split. And after they split, they start to look more and more and more different, you know? Anyway. Yeah. And how does the amniotic fluid, e.g. human, relate to amniotic eggs? I'm so glad you asked, HB. I am so glad you asked. Here, let's take a look.
Live young. In 1799, the keeper of the Department of Natural History
We'll get to it, but we're going to talk about the platypus
didn't know what
first.
to make of a bizarre specimen that had just arrived from Australia.
This is pertinent to our question because this is a mammal, but it lays eggs. But it'll help show how we've still got that same eggy stuff going on inside us today. if you're, if you're the kind of person who's going to give birth, I mean, I'm not going to do that, but more power to you. Yeah.
It appeared to be the skin of a beaver or a mole with a beak sewn onto it. Being a good curator, he carefully examined every inch of the specimen and published a detailed description of its many weird features. But he wasn't convinced it was even a real animal. He wrote, and I quote, "I ought perhaps to acknowledge that I almost doubt the testimony of my own eyes with respect to the structure of this animal's beak." The beak met the body so perfectly, and the animal was just so strange that, for a hot second there, he suspected that the specimen was a fake. But the arrival of more specimens confirmed that he was dealing with a 100% genuine creature, with the bill of a duck, the tail of a beaver, and the feet of an otter with venomous spurs. The animal, of course, turned out to be a duck-billed
Sharks
platypus.
aren't out. There you go.
Perhaps the weirdest thing
Sharks
about
are
it
not
was
in
that it was a mammal that laid eggs. The
Neither are
platypus
amphibians.
belongs to an unusual group called monotremes that diverged from the branch of the mammal family tree that leads to marsupials and later placentals around 186 million years ago. And although they might not look like it, eggs were a huge evolutionary innovation. They saved those animals known as amniotes from extinction and may have set the stage for their invasion of dry land.
So again, that was Hylonomus right there. This critter right here. One of the earliest of the amniotes. Yeah. Right after that split between reptiles and mammals. This is on the reptile side, but again, Archaeothyrus, this critter right here, this looks like a lizard, but this is like the earliest mammal line critter that we have so far. Anyway.
While the identity of the first animal to lay eggs is still a mystery, paleontologists can estimate when this creature came about and what it might have looked like. And they're teaming up with geneticists and biologists who study living animals to understand why and how most mammals lost this incredible egg-laying innovation.
Yep. Raven says, quick question, how much do you think one person can learn in a day about fossils? Quite a bit, I think. Yeah. Stick around here. You're going to learn a good deal, I bet you. Welcome to Paleontologizing. Welcome back, rather. Yeah.
Turns out that might have all started with a chance encounter with a virus. The story of the egg spans millions of years, from the first vertebrates that dared to venture onto dry land to today's mammals, including the platypus.
Prankster fan,
and
welcome.
of course, birds.
Yeah.
You know, like chickens? Yes, I'm here to tell you, fam, the egg came first.
Yep.
Okay, now there are eggs, and then there are eggs. The earliest eggs of any kind were laid in water, accompanied by a thick layer of jelly, like frogs do today. And yeah, it's literally just called jelly. And this jelly is a good home for amphibian embryos as long as everything
Hey,
stays.
Grindhouse, yeah. Eons they do excellent work, and they're often kind of a great springboard for conversation about topics like this, you know? Yeah, welcome, Grindhouse.
385 million years ago, in the Devonian period, tetrapods started venturing away from the water's edge. Competition was high in aquatic ecosystems, and the only animals on land were invertebrates, like insects and spiders, which probably enticed tetrapod ancestors out of the water. But in order to become truly terrestrial, tetrapods had to be able to keep their embryos wet on dry land. One of the first vertebrates to live and maybe reproduce on dry land was Cassinaria. It lived during the Carboniferous period, around 334 million years ago, in what's now Scotland. And it mixed some of the amphibian features of its ancestors, like unfused shoulder bones, with features associated with reptiles, like strong leg and backbones. And some experts think it resembled a new group of creatures that would appear in the fossil record about 20 million years later. The first true amniotes.
Like
These
Hylonomus.
animals laid a new kind of egg, one surrounded by a tough, leathery shell. The shell helped protect the embryo from diseases and attacks, but was also porous enough to let gases reach the embryo so it could breathe and grow. And the waterproof membranes and the amniotic fluid inside the egg created a self-contained pond so the embryo stayed hydrated. And you gotta stay hydrated. Suddenly, animals didn't have to spend their lives in the swamp anymore. It was a huge boost for adventurous tetrapods that were colonizing dry land. Then, parts of the planet that had been tropical and humid started to cool and dry up, an event called the Carboniferous rainforest collapse, which I've talked about before. The swamps began to disappear, and many amphibian groups went extinct. But the amniotes, being better adapted to drier conditions, expanded into a variety of new niches and dominated the land. But what were the steps between embryos and jelly and embryos and shells? Well, we don't know, because of what's known as the egg gap. Some of our earliest fossil records of amniote eggs are from dinosaurs, like Mesaurus patagonicus, which lived around 215 million years ago in Argentina. And that's at least 100 million years after when we think the egg first appeared. So the initial 30% of the history of the amniote egg unfolded without leaving a trace. Because eggs, especially soft-shelled leathery eggs like we'd expect to see in early amniotes, don't fossilize well. So without that proof, paleontologists have to rely on inferences based on closely related animals for which they do have hard evidence, a technique known as phylogenetic bracketing. Since reptiles, mammals, and birds are all amniotes, amniote eggs must have existed in their last common ancestor, the first true amniote. Fossils of the earliest unquestionable reptile, and therefore the earliest known amniote, come from Nova Scotia and are dated to around 310 million years ago.
Hylonomus, like
from
I
a
was
cute
talking
little creature called
Yeah.
Hylonomus. So the egg must be older than that. What we do know is that the tail of the egg diverged into two separate storylines around 315 million years ago, when amniote split into two major groups.
And so again, when I say that the split between synapsids and sauropsids, between mammals and reptiles respectively, happened before the first fossil record of reptiles, this is what I mean. So Hylonomus, it's about 310 million years old. It is the, like you said, the oldest unquestionable reptile that we have thus far. Yeah. And so this old trope about mammal-like reptile, you know, mammal-like reptiles. This is completely wrong. Just the wrong way to think about things. These guys are not reptiles at all, at least not like Gorgonopsia in there. And things like Cotylorhynchus here, not a reptile. These are stem mammals. They are on the mammal side of the family tree. That split happens before you get reptiles and mammals. Like, these can't be reptiles because they're not descended from reptiles. Does that make sense? So, like, that whole phrase, mammal-like reptile, completely incorrect. Yeah.
Storylines around 315 million years ago, when amniote split into two major groups.
There we
One
go.
was the sauropsids, which would include reptiles, dinosaurs, and birds. The other was
Yep.
the synapsids, the ancestors of mammals.
Yes, indeed. And Alexander Morrison, yeah, good point. Sauropsids are reptiles, synapsids are mammals. To simplify things, there's also like weird stem groups that come off. We've got stem reptiles and parareptiles and things like that. And then you've got stem mammals and, you know, weird like mammal ancestry type things that are not true mammals. But anyway, let's think of this as a divide between reptiles and mammals, you know?
Surely, one of the most remarkable animals that has
well.
ever existed, and certainly one of the most famous,
Is Suavorio.
is a dinosaur.
This is my birthday gift to myself. I was gonna wait until Thursday birthday, but it's okay.
I appreciate you very much, Suavorio. Thank you for that continued support. 2 months there. I appreciate that very much, Suavorio. Thank you for that. Good stuff. Yeah. Good stuff. Yeah, what I was gonna say here is that, yeah, think of this divide as between reptiles and mammals. We'll just simplify it. Yeah. Well, we're not going to talk about stem groups and crown groups and all that. Just think reptile and mammal to simplify things. Kind of get this idea established. And there are certain critters like Dimetrodon right here. Here's my Dimetrodon skull. This is not a dinosaur. It is not a reptile. It is on the mammal side of things, from the mammalian side of the tracks, you know? And I even did a TikTok about this a while ago. It's crazy that I've got 286 followers, and I only have this many TikToks. It's not very many at all. Anyway, here, take a look at this. I am just getting ready to carve up this pumpkin. I thought everybody's going to be expecting me to do a dinosaur, so I'm going to buck expectations a little bit and do something that is distinctly not a dinosaur and make it be about not being a dinosaur. You can tell me what that is. Dimetrodon, there you go. Yeah, Dimetrodon. This critter is more closely related to you and me than it is to any dinosaur, which is pretty cool to think about. These are very, very charismatic animals. You see them in all kinds of assorted plastic dinosaurs boxes and stuff. But they're not dinosaurs. These predate the dinosaurs by, what, probably a solid 60 million years? Let's go ahead and get started with pumpkin carving. First thing that I've got to do for this is carve out the top. Unfortunately, I don't have any anesthetic for our pumpkin friend here. It's time for your lobotomy. There we go. Look at that. Pulling out all the guts right here. You see it in a movie or a book or something like that, and you can say, hey, that's not a dinosaur. That's a Dimetrodon. Yep. Check it out. Ah, that looks so much better now. Ha! Very nice. Very nice. Our, not a dinosaur, Dimetrodon. Let me turn off all the lights. Ah, yes. Check that out. Oh, man. That is pretty cool. I like that a lot. It was a lot of fun. I'm pretty happy with this. Anywho, that critter, Dimetrodon. When you think of it as... Well, shoot, when you see illustrations of it with hair, like this one right here, it kind of becomes easier to think about as a, you know, on the line to mammals, on the mammal side of things, rather than being on the reptile side of things. But anyway, yeah. It's a synapsid, not a sauropsid. So as soon as the first amniotes evolve, you've got a split between them. When critters start laying hard-shelled eggs on land, they start to diversify, and they start to really take over, and they evolve into these different groups.
And these two groups put their eggs in very different baskets. Sauropsids mostly kept laying eggs throughout their evolutionary history, although they'd end up laying different kinds of eggs. Some reptiles continued laying eggs like those of early amniotes, which were soft and leathery, like turtles still do today. But birds, and their predecessors, the dinosaurs, eventually started forming a different type of egg, one that had calcium in the shell. This made them much stronger and also more likely to fossilize, which is why we have those fossil eggs from the saurus. Now, the other group, the synapsids, took a much more complicated path. Like sauropsids, early...
And hang on, Gazaway says if it's a mammal, that means it regulates its body temperature, right? Not necessarily. That's not what makes a critter a mammal. Most mammals today do that, although some mammals are kind of cold-blooded. They kind of rely on the external ambient temperature to maintain their interior body temperature. Sloths are kind of like this. They're not very good at regulating their body temperature. But they're still mammals, you know? So we're not sure about Dimetrodon or about critters like Ophiachodon right here. They may have been endothermic, warm-blooded, regulate their own body temperature, or they may not have been. We're not really sure.
Synapsids probably laid primitive amniote eggs with flexible shells, but there's no fossil evidence of their eggs either. But we know that in just over 100 million years, the ancestors of mammals made huge strides. They went from scaly, lizard-like creatures like Ophiachodon to fully warm-blooded, furry creatures with mammalian jaws and middle ear bones. And at some point, synapsids even evolved mammary glands when they were still laying eggs. At first, these glands possibly served as a source of water to help keep eggs hydrated. But later, they became a source of milk for feeding young after they hatched. Milk is something that all mammals do, even the ones that lay eggs. Enter the monotremes. This new group of synapsids branched off around 186 million years ago during the early Jurassic period. This was the last group of synapsids to branch off that still laid eggs. And these ancient egg layers probably reproduced a lot like today's monotremes do. The mother platypus, for example, keeps her fertilized shelled eggs inside for a long time before she lays them. While they're inside, the embryos take in a lot of nutrients from the mother and are developed enough that they hatch in less than 2 weeks. And we think monotremes have been doing it more or less that way this whole time. But finally, around 100...
So don't think of platypus eggs as being like chicken eggs. Platypus eggs apparently take a long time to develop inside of the mother. And so there's like, in essence, an umbilical cord running to the eggs. And then when the eggs come out, they don't take very long to hatch. He said, what, 2 weeks?
60 million years ago, in the late Jurassic period, the ancestors of placental mammals and marsupials.
Pouch egg, kind of.
These were the therians, like Juramaia, a toothy, shrew-like mammal known from China. Now, the steps that happen between having eggs and having actual pregnancies in our mammal ancestors are mysterious. Because, you guessed it, there's not much fossil evidence. But, once again, researchers can turn to living mammals to try to figure out what happened. One piece of the puzzle could be changes in gene expression. Because the main membranes of an amniotic egg, known as the sac, the chorion, and the allantois, are all present in animals that give birth to live young. They're just used in different ways.
We still have them.
Mammals still form an amniotic sac around their young. But the placenta, the organ that provides material to the embryo from the mother, is actually formed from the chorion and allantois membranes of the egg. So mutations may have changed how the pieces of the amniotic egg were used, leaving mammals with an entirely new reproductive strategy as a result. Another idea is that therians followed a path similar to the monotremes, where eggs were retained in the mother's body for longer and longer periods of time. And this—
That's exactly what Charlie's Dragon just typed into the chat. My guess is that they kept the eggs inside them for longer and longer until the shell wasn't needed. It would make sense, you know? Kind of that stepwise process like that.
Where eggs were retained in the mother's body for longer and longer periods of time. And this also might have happened through changes in the expression of genes, in this case in the genes involved with egg retention or embryo development. Yet another piece of the puzzle could be unusual proteins called syncytins. These proteins help cell membranes fuse together, and their most important role in mammals is developing the placenta. What's interesting about syncytins is that they didn't evolve in mammals. They've been part of our genome since before therians were even a thing. Syncytins are actually what's left of an ancient form of glycoproteins, which make the outer shells or envelopes of some viruses. But they're also found in modern mammals. So, researchers think that more than 190 million years ago, some retrovirus attacked one of our mammal ancestors and inserted bits of its genetic material into its host DNA that made that viral protein. And over time, that viral DNA was repurposed into new genes in mammals.
So this is something that viruses can do, is that they can actually, like, they can alter genomes to a certain extent, which would be necessary for this to be heritable, you know? Which, if this is how it came about, then... Yeah, interesting stuff. Really interesting.
So today's mammals, including you, still carry pieces of this ancient virus with them. But instead of connecting parts of a virus together, they're used to build a placenta. So it may be that a chance encounter with a virus kick-started the process that led to mammals no longer laying eggs. The evolution of the shelled egg was a milestone in animal evolution, helping those first amniotes take over the land. And the sauropsids and the synapsids put their own spin on the amniotic egg, ones that we can see today in living birds, like the chicken, and in monotremes, like the platypus. So by digging into the genomes of these living amniotes, we can start to tell the story of how and when the egg came first.
Pretty cool stuff. Another excellent video from PBS Neons. I hope that was helpful for understanding these concepts. But yeah. Bondo Latour says, I can feel my neurons connecting. This is fascinating. Isn't that pretty cool? Yeah. Fascinating stuff. Yeah. I don't know how we got here from talking about Microraptorine dromaeosaur trackways, but yeah. I guess we were talking about irreversibility in evolution. That's how we got here. Yeah. Anyway. Yeah. Good stuff. Here's a link to this press article here. And we'll take a look at the original paper here, too, which came out in October. I guess I was getting ready for SVP at the time, which is why we missed this. Yeah. Oh, and we just got a shout out from Casey Snowart. Well, let's return the favor there. Good stuff. She's got 61 people watching. That's awesome. Good for her. She's gonna get partnered pretty soon, I think. Demon Prince says the ability of viruses being a vector to transport genetic information or change the genetic information of cells is heavily researched for drug development nowadays. Yeah. If we could do some of the same stuff that you could do like in CRISPR using viruses, holy cow, that would be like a major breakthrough. It would also be something to be really careful about because viruses can reproduce themselves and they can go out of control, so yeah. Gazaway says laying eggs seems like it'd be much safer for the mother than live birth, but I suppose having more mobile children rather than defenseless eggs would also be a huge benefit. Yes. Different strategies, you know? The fact that dinosaurs laid eggs rather than giving birth to live young may have been one of the major keys to their success. especially when we look at like sauropod dinosaurs. Some of the biggest of which were, of course, the biggest animals that have ever walked the earth. If they had to carry great big babies inside of them rather than small eggs, that probably would have restricted their ability to get so large. And also, it may have led to premature extinction if they had given birth to live young. Because you can't have as many young that way, you know? With like a K reproductive strategy rather than an R reproductive strategy. This is, sorry, I'm getting a little bit into the weeds with this. But, here. This is a really neat paper. Kind of discussing why sauropod dinosaurs may have been able to get so big. Part of that is egg laying, we think. Fast population recovery. Yeah, many small offspring in eggs means you can have a high rate of reproduction, which means you can have fast population recovery, reduced extinction risk, and that in turn can help you achieve very high body mass. It could be that giving birth to live young is a kind of retarding force on mammals getting super large on land. It could be a restriction, potentially. The biggest mammals that we have that have ever walked on land are either the Paraceratheres or big proboscideans. So, here we go. Goodness, why is this on Reddit? I hate when the images are on Reddit because we can't really embiggen them properly. But, whatever. Here are some of the biggest mammals from various groups. You know, biggest predatory mammal on land, polar bear. Tallest mammal today is a giraffe. Here's Paraceratherium, which is one of the biggest terrestrial mammals that's ever lived. It's a type of hornless rhinoceros. We've got really big elephants like Paleoloxodon. And then you've got modern elephants and rhinoceros right there. They're all dwarfed by some of the biggest sauropod dinosaurs. They're so much smaller. And part of the reason is that, well, they've got to carry a great big embryo inside of them. They don't lay eggs. And when you're a big animal carrying a great big embryo, it kind of restricts your... You've got to devote so much muscular strength and energy and everything to also carrying around that embryo inside of you that you can't get all that big yourself. So it's probably one of the reasons why these guys never even approached sauropods in maximum size, you know? So yeah. And Bondolator says marsupials really are peaked. Small young that are less harmful to birth, they can easily carry externally during development. It's a strategy that works for them really well. But also thinking about these restrictions that are inherent in a situation like this. Since marsupials since they have to be able to crawl from the birth canal into the pouch, that's a restriction right there on them. Like, this is a newborn kangaroo right here. Newborn Joey. Well, crawling up its mother's fur to get up into the pouch out of the birth canal. You've got to have arms with digits on them that you can pull yourself up with. So we'll never have marsupial whales, you know? We just won't. Because you have to have arms with fingers. So it's interesting to think about, you know? You could never have a marsupial born with flippers. It just wouldn't work. Because at this critical early stage, you have to be able to grab with your little arm nubbins. These guys are so tiny and underdeveloped, they don't even have legs yet. It's just these little... There's just like a little flesh being with tiny little arms, you know? They don't even have developed jawbones yet. It's just... They've just got like a little tiny hole at the front of their head. Yeah. Trying to find you. Yeah, there we go. Just like that. It's nuts just how small they are. Just a little flesh jelly bean. Yeah. But yeah. I'm not condemning marsupials and saying, oh, they're no good because they could never evolve flippers. It's like, no, it's just not for them. It's not a thing that they'll do. They're on this evolutionary path that precludes the ability to become marine and evolve flippers. It's not going to happen for them. And it's fine, you know? Yeah. And Bondo says, marsupials not peaked, just niche. Thank you for being such a good teacher. You bet, Bondo, yeah. I appreciate the kind words. Nobody's peaked, you know? Creatures are well adapted to their circumstances, to their environment, to their niche, you know? So, I don't know. It kind of bugs me sometimes when you hear in pop culture somebody will say, well, you know, sharks are perfect organisms. They are perfectly evolved. They are you could never improve upon them. Like, what do you mean you can't improve upon them? That's what evolution is. That's why they're still around, is that they are constantly improving all the time. Living things are always changing, generation to generation. It never stops. Those changes might be very subtle in some cases, or more dramatic in others, but you always have some degree of evolution happening, you know? It's just how it works. Nerduino, how are you doing? Hello, hello. It's good to see you, Nerduino. Yeah, this is why I desperately wish that evolution were better taught in American schools and in schools all over the place, you know? So, yeah. Anyway, I hope that makes sense. Let's get rid of some of these tabs and, yeah. Shall we continue with our fossil news here? With the Microraptorine story here. These guys were flapping their arms while running. Here is the paper there. And it is open access. Here is a link, in case you'd like to access it there.
Access granted.
Theropod trackways as indirect evidence of pre-avian aerial behavior. This is so cool. I'm a little embarrassed I didn't see this when it came out, but I was getting ready to go to big scientific conference, you know? Very cool stuff. And Raven says, oh, J.R. Hansen. Thank you, Raven, for signal boosting J.R. Hansen's post there. Sorry I missed it. J.R. Hansen says, my daughter Esther was wondering if you could give her a shout out. A little while ago, you gave a shout out to her brother, and she got jealous. We've said this 3 times now. Sorry about that. There's a lot going on in the chat. I get pretty animated about these things. Talking about science. But Esther, if you're still watching, thank you for watching. I hope you're having a good time. I hope you're learning a thing or two. Also, it's so exciting to learn about the history of life on Earth. And I'm grateful that, you know, you'd sit here and watch this. Thanks for being curious, and thanks for being persistent, too. Sorry it took me so long to get to your message, but I appreciate you, Esther. Hope you're having a good day, too. Thanks for being here. Anywho. And Prankster Fan says, yay to Esther and her brother, and 10 points for their parent for being rad. Agreed. Yeah. Yeah. Appreciate you, Esther. I do. Thanks for watching. I hope you're... Yeah. Trying to make sense of this figure here. Preserved ground tracks. ground surface between tracks. Oh, there we go. So we've got tracks here, tracks here, tracks here. Big gap in between. What in the world is going on? Our results suggest that trackway 2 records a microraptorine engaged in aerial or partially aerial behavior. So it's flying or flapping, involving coordination between the forelimbs and the hind limbs. We cannot make any claim linking a specific aerial behavior to the trackway, like launch, landing, accelerated downward glides, or wing-assisted stride extension. We can say that the track making involved a behavior featuring aerodynamic force production and contact with the substrate. Thank you, Joe Electronic, for the follow. Appreciate that. Welcome, welcome. The trackway therefore provides indirect support of wing-assisted behavior in action outside the lineage directly leading to birds. Previously only hypothesized. There we go. So you could almost call it wing-assisted incline running, like we've talked about before, but it doesn't seem to be on an incline. Normally, trackways like this, you only find them on level ground, because that's how these things get buried in the first place. You're not going to find it on an incline. Yeah, pretty cool. But yeah, you could chalk that up. More evidence for wing-assisted incline running. It's neat stuff. And yeah, this is so funny. Like, animals running. If we just take this as normal running behavior without flapping or hopping, then this animal would be like moving so much faster than a cheetah. That's nuts. That's really funny. Yeah. Comparison of relative stride length between trackway 2. Yeah, extant terrestrial high-speed specialists. That's neat. Anyway, cool stuff. I buy it. Again, really cool that we can find dinosaur trackways and infer what these critters were doing while they were alive. Gives you information that you wouldn't have from just a skeleton. You know, from something dead. And Oscar Juniors, thank you for the 5 gift subs there. I really appreciate that. Thank you, Oscar Juniors. Good stuff.
Oscar JRS just changed things with those 5 gift subs.
There are 5 people in the chat now who won't have to worry about any ads for the next month. Thanks to you, Oscar Juniors. I appreciate you for it, and I know they do too. Thanks for supporting Science Outreach here on Twitch. Thanks for keeping me going. Appreciate it. Gonna be done before you're 16. Nice, Raven. Okay. Well, shoot. You're on the fast track. That's awesome. Before I forget, let's check on our 3D printers right now. I'm gonna have to get used to saying that now that I've got 2. Again, I'll be talking about this tomorrow. Special announcement tomorrow. Something I've been looking forward to announcing for a while, but a really exciting new project. One of the reasons why I got a second 3D printer. We'll be talking about that. But yeah. Good stuff, Claire. Yeah, I'm excited too. I am excited. Anywho, I showed everybody earlier. I guess I can show it off again. Currently printing a life-size gharial skull. Here. Decent part of it's already done. I was able to get the printer working on Saturday morning, and I got 2 printers. I can print big projects twice as fast. So let me show you something I've been working on over the weekend. Here we go. It's the wrong side. There we go. There's still a bunch of supports on here. I haven't had time to take them off yet. So that's why it's going to look a little wonky. A little bit hard to figure out. Let's get rid of this bottom part so it'll lie flat. There we go. It is a gharial skull from a fish-eating crocodile like this, crocodilian. Gavialis gangeticus, printing a life-size gharial skull. I can't wait. This is one of my favorite animals. It's exciting stuff. Dream Lucid Wizard, thank you for the follow. I appreciate it. Welcome to Paleontology. It is gonna look so good, Lenina. Holy cow, I can't wait. And like the one at the San Diego Zoo, yes indeed, Miss Yvette. Yes indeed. Anyway, we'll be assembling this on Wednesday's stream. Gharial Skull Assembly on Wednesday's stream, so tune in for that. It's gonna be a lot of fun. Can't wait. Anyway, we'll be talking all about Gharials on Wednesday. Neat stuff. Alright. Why don't we talk about something else right now? We're gonna switch gears a little bit here. And we're gonna talk about some fossil news that I am less than completely excited about. Yeah. Here. You've probably heard about this in the news, maybe?
5, 4, 3, 2, 1. We are thrilled to unveil the magnificent Stegosaurus specimen Apex.
Yeah. So
today...
You might be asking yourself, well, Danny, why is the unveiling of a beautiful Stegosaurus skeleton not necessarily a good thing? Not here to rain on anybody's parade. I'm really happy that these people get to see this. I'm glad they're excited about a dinosaur. I'm glad that this was part of their weekend. That's really cool. I'm all for that. This particular specimen is a commercial specimen, meaning it was dug up by a private group and then sold to a billionaire, and it was sold for, it's like $40 million, which is more than any other dinosaur skeleton has ever sold for. And this is bad news for paleontologists, because it shows that scientifically important specimens are being turned into commodities to be sold, almost like the way that art collectors will spend exorbitant amounts of money on, on pieces of art. We're starting to see our scientific specimens become commodities in the same kind of way.
We unveiled a new specimen that's on loan here at the museum, Apex, which is the most complete Stegosaurus specimen found.
Yeah, it's amazing. It's really incredible.
So for this one, this specimen...
Yeah. I didn't get a chance to really talk about this a whole bunch during the summer, because I was in the field. But this happened, I think, just after we got to Utah. Yeah. Let me look at the chat, see if anybody's got any questions. Yeah, and the spice is because we can't study it? Well, right now, yes. it's not... If it were to be donated to the American Museum of Natural History, then it could be studied. It could be published on. But it's not. This is the private property of a very wealthy person. And rather than donating it to a museum or something, which could allow it to be studied, he wants to keep it as his private property. You can make an argument that, like, hey, you know, you bought it, fair enough. Sure. But I almost feel like AM&H here is... They're celebrating this thing that... They're celebrating the commodification of our science, you know? So yeah. It feels like they're endorsing the commodification. I agree, Charlie's Dragon. I agree. Yeah. Boy, let's look at the Sotheby's video, I guess. Oh boy.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My name is Jason. I'm lucky enough that my hobby and career is both finding and excavating dinosaurs.
And you know, from what I've heard, Jason's a really nice guy. And I've got colleagues who are close to him, who have worked with him before. So yeah, I feel like I should say that right off the bat. But that doesn't necessarily excuse the harm that this sort of thing can do to our science, you know?
I've been digging fossils, dinosaurs, my entire life. Often you don't know if it's just going to be a couple bones. 9 times out of 10, it'll just be like a random 1 or 2 bones. And then lots of things as people have to think about is the dinosaurs aren't buried usually as complete skeletons. Just think about on the side of the road if you see...
And the spy says, so does Jason own Apex or someone else? So he dug this up on private land, which under United States law means that it belongs to the landowner. So I guess he made a deal with the landowner. His team excavated this, and then they sold it at auction. And it sold for like $40 million. What was the actual figure? $44 million. Yeah. To put that into perspective, you could take that amount of money and you could establish a fossil museum and a field program funded in perpetuity. You could provide it with an endowment so that you could go out and find 100 Stegosaurus specimens like this over the decades that are just as good. It sometimes takes a remarkably small amount of money to go out and actually excavate a dinosaur. Like, I've been on field crews before where we've had less than $1,000 for an entire summer, and we've brought back a whole bunch of really important dinosaur fossils, some of which are currently being worked on, and they're going to be some really cool scientific papers that are going to get a lot of attention. Dinosaurs are not big money. We as paleontologists do not get paid a lot, if we get paid at all to do field work, which I don't, you know? So this is taking big sums of money and introducing this into a field where, you know, we're just scraping to get by. Does that make sense? Yeah. Here, here, let's take a look at this little video to kind of help set the stage. This is from the Wall Street Journal from a few years ago. Inside the battle over dinosaur fossil hunting. This is a bad title. It's the commercial fossil trade that is what's at issue here.
I think that there's several reasons to own fossils. Science is only one of them.
I've made millions of dollars in the dinosaur business.
The thrill of discovery doesn't get old. It's almost like an addiction.
There is a fight going on in the world of dinosaur fossils. The market for these prehistoric treasures is booming, but increasingly wealthy individuals are buying up the best specimens, and that has paleontologists worried.
A rare baby?
And it's not like we're usually in the running to purchase these things in the first place. It's not, oh, the price is going up and we're being outbid. We normally are not in any position to buy any fossils in the first place. We're barely in a position to go out and dig the things up ourselves with our own, personal toil and everything, like our own labor. It can be difficult to scrounge together enough money in order to be able to feed ourselves when we're in the field, let alone actually make any money off of this, So, yeah.
T-Rex fossil is for sale on eBay. Some scientists and other critics are calling the listing a disgrace.
Last year, a baby T-Rex fossil was listed on eBay for $2.95 million. The sale outraged many paleontologists. According to a letter from the Society of Vertebrate Paleontology,
SVP.
If the fossil was sold to a private buyer, it would effectively be lost to science, since private buyers are under no obligation to share their fossils with researchers.
The scientific community is trying to hurt us. They want to discourage anyone from making money selling fossils. I tell you what, I've been charmed. Had a charmed life, and it's all because I pick fights, and I'm picking.
Oh boy. Yeah, Dietrich here is, yeah. Real piece of work. Let's say that. I'm gonna kind of hold my tongue about this a little bit, but yeah, people who have interacted with him on places like Facebook, I think he may have actually been banned from Facebook at this point. For saying some things about some particular groups of people, but yeah. Racodactylus says Danny is being way more polite than I suspect I would be if I were covering this. Trying to, Raco. Yeah.
Fights now, and I'm doing it in a different way. I'm going after the scientific community. They need to open up.
I think I agree that the scientific community needs to open up, but not in the way that he means. Not by commercializing things further, but by making things more accessible for other people to be able to study fossils. There are a lot of really enthusiastic, sometimes gifted people who they try and get into fossil science because they're passionate about fossils. They want to make a difference in paleontology. They want to help drive the field forward, and they're being forced out because academia is kind of an old boys club in a lot of ways. It's very gatekeepy, and there are not nearly enough jobs, and there's stiff competition for these things. And so people that would have been brilliant paleontologists, who would have been in a position to contribute to the field of fossil science, instead they get kind of pushed to the margins, and some of the people who are a little bit more driven there end up becoming commercial fossil dealers. Because they still want to work with fossils, and that's a way that they can do that and make a living. And I understand that, As somebody who's got a very, in some ways I think, unconventional way of making a living in paleontology, I get that. You do what you gotta do in order to be able to continue to work with fossils. So, yeah. So I get that. Science does need to open up, but not in the same way that that I think he intends by overly
Owen Dietrich
commercializing
is a commercial
things, you know?
fossil hunter selling the baby T-Rex.
This is son of Samson, the smallest Tyrannosaurus rex dinosaur in the world.
And that's not true. Chomper Rex is smaller, a Tyrannosaurus specimen that I helped excavate in 2013 and 2014. Much smaller than this one. Yeah.
Son of Samson was found in 2013 near Jordan.
A very funny militant vegan.
Dietrich's T-Rex is a scientifically significant find.
And this is actually supposed to be Mamenchisaurus right here, which is, not Diplodocus. The Diplodocus is over there. But yeah. Anywho.
Which is why he had hoped to sell it to the American Museum of Natural History.
It's an important specimen. He has made a big effort to try to get it into a public institution. We were interested in it, for instance, but it just didn't work out. It purely comes down to an issue of price.
Dietrich told the Wall Street Journal that he offered to sell...
So AM&H is kind of loaded. Like, they've got a tremendous amount of money. They also have very wealthy donors who are willing to pay out of pocket for something like this, too. There's other institutions that do that sometimes. The North Carolina Museum of Natural Sciences, they apparently had a donor who was willing to fork over, I don't know how many millions of dollars to buy the dueling dinosaur specimen. These are rare exceptions. Most museums are struggling just to keep the lights on. But sometimes you get situations like that, where somebody's willing to, like, purchase a fossil off of the commercial market like that and donate it to a museum. And that can be cool, but sometimes I wonder whether it's helping exacerbate a problem by driving the price up for dinosaur fossils to the point where we're not going to be able to access, private land in a lot of cases because commercial people are moving in. And they're getting a lot of these specimens and then selling them to people overseas and stuff like that, So, anyway.
Sell the dinosaur to the American Museum of Natural History for $1 million, which was about $2 million less than the asking price.
Usually, like
I'll see you around, Snowball. Thank you for being here.
For a long time, it's either not that good or they're asking too much money, so it gets kind of stale.
But Dietrich has been in the fossil business for decades, and he's confident that he'll find a buyer.
If you can't wait, you'll spend too much or you won't make enough money. This material is 65 million years old.
66.
I can wait a few months. I can wait a few years.
How lucrative is hunting for fossils? That depends upon how lucky you are, how skilled you are, how much time you have to dedicate to it, and how much money you have to invest in it in the first place.
Yep.
Although the commercial market is thriving, that doesn't mean it's easy to make a living as a fossil hunter.
I wear many different hats. So I'm assistant professor at Mayville State University. I teach biology, ecology. That's the day job. If I have enough time to come out here to the Badlands, I switch hats, and become the Indiana Jones or the Jurassic Park character.
This is one of the best places on Earth to find fossils. Every year, thousands of fossil hunters flock here to the Badlands to try their luck at finding buried treasure.
So I was working with Museum of the Rockies and then with the Badlands Dinosaur Museum. Where our fossils belong to the people, There's a really, really important distinction that I should make here, and I don't even know if they make it in this video. If not, that's like a huge missed opportunity. But the difference between fossils held in a private collection and fossils held in a public museum, it's night and day. In a private collection, those fossils can't be studied by scientists. Or at least, we have ethical rules about that, where in science, we need to be able to go and check each other's work. And there's a time component to that, too. So, say somebody publishes on, a Dimetrodon skull. This one's 3D printed, but, They make some claims about this, they publish it in the scientific literature, and say that was 100 years ago, and I want to check those claims. I need to be able to look at that same specimen. So it needs to be in a place where we know it'll be there for time immemorial. It has to be in a museum. It has to be held in the public trust. So when something is in a museum, like in a public fossil repository, there's a guarantee that that will be there decades or centuries into the future. Hopefully millennia. You don't get that kind of a guarantee with private collections. Private collections can be sold off. They can be, seized by creditors. They can be lost in a divorce or in a fire or in a flood or something like that. When fossils are in a museum, that is the primary purpose of that institution, is to keep those things there in the public trust, not owned by any individual, but there to benefit the public and to benefit science. Does that make sense? That's why we have rules against publishing on fossils that are privately owned. It's because there's no guarantee that it's just going to be there next year. And so science would be harmed as a result. You would have irreproducible results. Like, you can't go back and test old ideas. Science is, at its heart, all about testing. And if you can't test old ideas, then you're nowhere, So yeah. And 88 Mushroom says, well looked after and cared for museums are so important. Yes, absolutely yes. So yeah. And yeah, Rhacodactylus says fossils are data, and if you gatekeep data, you harm science. Exactly. Well said, Reiko. That's just ding, ding, ding. That is very succinct. I love that. Yeah. Anywho, back to this.
Recently, one of the lucky ones was Michael Jelland, who runs a small, non-profit fossil hunting company. To survey the land, Jelland worked out a deal with the private landowner to split the sale.
One day I was out walking and I went up into this box canyon. In the distance, there was some white-colored dinosaur
A good
bone.
first chat message, 88
wow,
Mushrooms.
this is a brow horn.
Glad you're here.
And that's
Welcome.
how we found Skull X.
Skull X refers to the fossilized skull of an adult Triceratops, which Jelland is working to excavate. But digging the...
Oh, there's the occipital condyle right there. So this is the... Tell right at a glance. Bam! There it is. This is the back of the skull where it attaches to the neck. Kind of ball and socket joint. Rhacodactylus says, interestingly enough, I'm very hooked into the open science movement. For all the talk about need for open data, I haven't seen much discussion about fossils yet. Wonder if there's a paper to be written about that by you and your paleo colleagues, Danny? Interesting, Reiko. I think we kind of already have that. There's already an assumption within dinosaur paleontology, vertebrate paleontology in general, that like those fossils are available for study. After you publish on them, all you got to do is email the museum and be like, hey, I'm a researcher. I want to look at this and this specimen. Can I come do that at some point? And yeah. I say after publication because sometimes there is some gatekeeping that goes on before something gets published. Sometimes people sit on things for decades. There's sometimes good reasons for that, and there's sometimes less than good reasons for that. But, yeah, I think we already, kind of at the heart of our discipline, there is a commitment to open data in the sense that the fossils should be able to be studied by anybody. Yeah. Paleo's tradition of open data is a model for other sciences to try and emulate. I don't think it's just paleo either. I think it's, well, maybe it is particularly pronounced in paleontology. But other sciences like that use specimens, zoology, botany, other like specimen-based research, I think has basically got the same kind of idea. Like, you have to have specimens that are in a public repository. I think it's the same in other specimen-based research too. Yeah. Anywho, but I like that idea, Reiko. I didn't think about that. publishing a paper on this would be interesting. Yeah. Dossie, oh boy. Dossie says, it's a good thing we don't allow private ownership to hinder our access to more contemporary scientific endeavors, like newly discovered chemical compounds with the ability to save and improve on the lives of billions. Yeah. Again, you introduce big money into a system like this, and things kind of fall apart. Yeah. Has he? Oh boy. Yeah. Anywho. But yeah. St. Everest says, What are you mulling over? Curious to know. Anyway, let's continue this.
Digging the skull out of the ground is only the very beginning of the process of getting the specimen to market. Once the fossil is secure in a dry jacket of plaster of Paris, Jelland will need to move the approximately 500-pound mound of dirt and rock across this ravine and then up and out of this canyon.
That's going to be tricky.
For Jelland, digging up fossils is a labor of love. He knows that he will likely only break even on Skull X, but that doesn't matter. His primary interest is science.
The reason why I decided to set Fossil Excavators up as a nonprofit, because I'm not in it just for the money.
I've made millions of dollars in the dinosaur business. You know, I love capitalism.
Oh boy. Good for you, bub. Sure, it's worked out well for you. I don't think he's made millions of dollars. I think it's the kids would say, I think that's cap. But yeah.
Because the people that get to the top of the hill get to do what they want to with their money.
Oh yeah, and surely that could never be a bad thing. I'm sorry, what did he say there?
Dinosaur business. You know,
I don't trust this guy either.
Capitalism. Because the people that get to the top of the hill get to do what they want to with their money.
Yeah, and then afterward, they get to take it into the afterlife, too. Along with, all of their servants, who are done away with and buried alongside them, you know? And that's the most important thing at the end of the day, right? Is that you can be wealthy in the afterlife. Yorveko, yeah, I know, right? I know, right? Yeah. Anywho.
Welcome to my studio where I clean and prepare fossils. I've sold thousands of fossils. Right now I have a 30-year accumulation of Triceratops dinosaur bones and T-Rex dinosaur bones and Edmontosaurus dinosaur bones and some new to science bones. I don't know what they are.
I mean, they're from the Hell Creek Formation. There's a good chance they're not new to science. The Hell Creek is very intensely studied. But the idea that he thinks that they're brand new and he's like, yeah, well, who cares about the science? I'm here to make money, Oh, boy. Yeah. He doesn't know what they are, but he sells them. Yeah. Ms. Yvette says, what if you ask nicely to the person that bought the dinosaur fossil that someone wants to study it, and I will give you a shout out in the paper if we make a new discovery. It can't be in a private collection, Ms. Yvette. We were talking about this earlier. It can't be in a private collection. Because if it's in a private collection, then there's no guarantee it can be studied in the future. It could get sold the next day. It could get destroyed in a fire the next year, that kind of thing. It needs to be in the public trust. If a fossil is in a private collection, it might as well not exist as far as science is concerned. Does that make sense? There's really important reasons why we have these norms too. Yeah.
Like most commercial fossil hunters, Dietrich doesn't have a formal education in paleontology, but he knows his dinosaurs.
I'm sure he does to a certain
extent. He's an accomplished artist who can prepare and mount his own specimens.
And so this is somebody that I don't know, maybe not with his attitude, but somebody like him with comparable skills, they should be somebody who's along for the ride, helping us make new scientific discoveries. Like, we need to bring them into the tent. Again, maybe not this guy in particular, especially knowing what I know about him from people who have spoken with him, and been around him. Holding my tongue. But, like, there are lots and lots of people who are much kinder than this gentleman, who are also far more skilled, and they've been pushed out of academic paleontology, and that is a huge problem. It really is.
But perhaps most importantly, Dietrich has a gift for sales.
Wow! This is a 20-foot mosasaur from Kansas. This was 85 million years old, give or take 3 million years. Some people say 88 million. This is what you call the eye of the tiger here. This is what gets kids excited. Buyers, you've got to excite their imagination. And what I like to tell people is, you know, at some point, you're going to be able to ride this thing off into the sunset because your name will live on, that you own this dinosaur.
What? No. No, you won't. You will be absolutely forgotten that you were a temporary owner of a thing that was 66 plus million years old? That is completely false. And no music. Let me tell you why that's completely wrong. You don't get famous for buying a thing and owning it. You might be famous for discovering something new or bringing something new into the world like that, but just spending way too much money on an item is not a way to be remembered, especially not remembered fondly. You know? A way to actually be remembered for all time is to aid in the discovery of something like that. You could take 1/10 of the money that you would spend buying an overpriced dinosaur fossil. You could take 1/10 of that money and contribute it toward a paleontological expedition that might find 10 times as many things, including maybe some new species, and then maybe one of them gets named after you. And then you actually do have some degree of immortality there. You know, if your name is attached to that, you know, if you have a dinosaur species named after you, then that is, people will be using your name for centuries into the future. And you will be forever tied with that. It's like, wow, this person was well respected enough that a colleague or a colleague named a new dinosaur after them. That's the highest honor I think that a person can achieve. As a dinosaur paleontologist, that is the end-all be-all. To have a dinosaur named after you is absolutely top tier. You know? Yeah. I hope that makes sense. Yeah. And Arcos Dusty Fries says, no one remembers people from 50 years ago that had nice car collections. The ego is insane. It really is. That's an excellent analogy. I love that, Arcos. Welcome to Paleontologizing. I haven't seen your name here before. Welcome in. But yeah, just because you, as this, you know, short-lived mammal, happened to own a fossil like this that's 60 plus million years old, you know, that you purchased that, you know, I don't know, I just do not understand that mindset, you know? To discover something is entirely different. It's like, I was the one who found this. There's a degree of discovery in that, you know? You're finding something that no one else ever has before. It's the difference between inventing penicillin, discovering that, giving it to the world, and then purchasing the patent on penicillin and being like, oh, look how important I am. You know? Ugh. Anyway, what do you think, Mini Pie? Yeah, you agree? Let's get some feline detox here. What do you think, Mini Pie? Yeah. Thanks for giving us a little bit of a distraction here for a minute. Yeah. Oh, Mini Pie. Yeah. Yeah. Oh. Look, you left this treat here earlier. Do you want it? No. Why would I eat that? I left it here earlier. And then Sweetie Pie left it here too. She didn't want to eat it either. Yeah. Well, maybe you do want to eat it? Let's get some of the other treats and see if you like those ones better. These ones aren't dental treats, but they're also tasty. What do you think? You gonna eat those? It's like, yeah, I'll admit that. You're so spoiled, Mini Pie. You're so spoiled. And Chaotic Kitten says, lol, maybe it's stale. It's definitely not. It's from a brand new package. Just opened on stream earlier. Yeah. Do you ever give the kitties churu? I don't know what that is, Chaotic Kitten. I've never heard of that. Oh, Minnie. Every cat loves churu. I've never heard of this, Rhacodactylus. Are you all pulling my leg? Is that a made-up thing? You should look into that treat, Danny. We'll see. It's a kitty treat that comes in a tube. It's like kitty yogurt. Oh, interesting. Okay, squeeze treat. Maybe. It also sounds kind of messy. And if it's the sort of thing that I have to, like, squirt onto my finger and then... I don't know. We've got so many treats for the cats right now. Clearbur very generously sent us 2 bags of the dental treats. And we've got a huge carton of the other crunchy ones too. So yeah. They'll eat it from the tube as you squeeze, says SV Arkin. It's like astronaut cat treats? Anyway, maybe I'll look into that, but it's not... Yeah. Anyway, let's continue with this video here, shall we? Yeah.
Tiger here. This is what gets kids excited.
Yeah, boy.
Buyers, you've got to excite their imagination. And what I like to tell people is, at some point, you're going to be able to ride this.
I liked a lot of people.
Because your name will live on, that you own this dinosaur.
Oh boy.
Today, private ownership of fossils can be seen as controversial, but things weren't always this way.
Commercial fossil hunting has existed since the dawn of modern paleontology. One of our most important specimens in our own collection.
I mean, yeah, but that was before jobs existed for paleontologists in most of these cases. Like, it was a different time.
That's on display here on the 4th floor is a mummy of a duck-billed dinosaur. That specimen was commercially purchased from a legendary fossil hunter named Charles Sternberg.
And Charles Sternberg, yeah, is legendary and helped contribute to fossil science in ways that are almost impossible to overstate, I think. Yeah, I don't know. Big respect to Mark Norell, but this is a very, bourgeois attitude. I'm just going to say it.
So It's always been part of the game.
The modern commercial market took off in 1997 when Sue, the largest intact T-Rex skeleton ever found, was auctioned off at Christie's for $8.3 million.
That was
Everybody
insane.
was astounded
you know?
that specimen would get that much money. I think before that, nothing had ever been sold above like $200,000 or so.
Since then, the commercial market has boomed, driving up prices and making it harder for public institutions like museums to compete.
You know, most of the people in my field would go.
To me, it's not even like museums competing on pricing. It's like being able to get access to fossil specimens. We're often restricted in being able to access certain places because, like, oh, you talk to a private landowner about looking for fossils on their land, or sometimes even just traversing their land using a public road that happens to go through their land so you can get to federal land to prospect for fossils, and they say, no, pay me. You're after fossils, right? Fossils are big money. And, like, maybe that's illegal to restrict access on a public road, but it definitely happens, and it's happened to my crew before. You know?
Go for more regulation. I personally would go for less regulation because there's
and
a lot
there you
more
go, Douglas.
fossils
Yeah,
out there.
absolutely.
They're just being destroyed by neglect and erosion than there are paleontologists who can actually collect them.
Yep, that's true.
After days of careful extraction and plastering,
hang on, Arcos Dusty Fry says, can you fossilize a modern chicken? With enough time, you could, in the right conditions. Yeah, yeah. You could probably even do like, fossilization under laboratory conditions, I suppose. I don't know enough about this kind of thing because I don't really work on diagenesis. Like, that's outside of my realm of expertise. But there are paleontologists who work on the fossilization process, and they'd be able to tell you about that in greater detail than I could hope to.
Skull X is finally ready to move.
With a budget of a couple $100, how do you get it out there? We can't go out and rent a helicopter.
Yep.
What we do have is a crew.
We used to not have the budget for helicopters too, like, field crews like this. And then there was a, Museum of the Rockies and other institutions like that used to be able to phone up the Montana Air National Guard or other military units like that. And they'd be like, hey, can you help us out with something? We've got a dinosaur fossil that really needs to, come out of this really steep ravine and then be placed on a flatbed trailer for a truck. Like, can you help us out with this? And they go, yeah, that sounds like a really good training mission. And they would send a helicopter out, maybe something big like a UH-60 Blackhawk or something, and do like an airlift. And then everybody's happy. They get a cool training mission. They know that they're contributing to something that's, for the good of humanity. They're contributing to science. We get all of that help, and the fossil gets to come back to the museum rather than having to stay there in the ravine. Everybody wins. But then, apparently, some private helicopter companies lobbied the U.S. government to make that illegal. And so, instead of just doing that, we would have to spend, I don't know what, $20,000, $30,000, $40,000 out of pocket for like a 1-hour rental of a helicopter and pilot and all the fuel and everything. And so now we just basically don't get to have helicopters anymore in the field. Yeah, because of, businesses like that lobbying the federal government. I wonder if I can find you, let's see. I don't know if I'm able to find this. I should ask Jim about it, because he could tell you about it. Yeah, I don't have the... Let me ask him about it. But yeah. Yeah. Is it illegal to find a random pilot to do it? Well, they can't, because You might have a kind-hearted helicopter pilot who's got a ton of extra fuel and time who just wants to contribute that for free, I guess. But also, that's kind of why we pay taxes, you know, and that's one of the less bad things that you could do with the U.S. military, you know? We spend an obscene amount of money every year on the most lethal fighting force on the planet the world has ever known, and then we can't use it for public good. You know? Helicopters are extremely expensive to operate. Absolutely, Mikey likes. Yeah. $20, $30, maybe $40,000 for a small helicopter for maybe 1 hour of flight time. So yeah. Anywho, let's continue.
Crew, they have a lot of creativity.
We're using these metal pipes as a bridge.
This is the sort of thing that I've had to do before in the field.
Slide across here.
Yeah. Shoot. My crew this past year, led by Ethan Cowgill in Wyoming, they were able to get a jacket probably 2 or 3 times bigger than this into the back of a truck using only manpower. Frankly, I think it's even more impressive than this, what they were able to accomplish. But yeah, you got to get really, really creative in situations like this.
I think the commercial market has a place.
Okay.
The financial side of it gives a motivation for people to go out and look for them, to conserve them. Some of them just are so remote, they might not even be found. Now, the bad side of the market is people can make up things, and maybe they'll
that
make
happens a lot
because they weren't properly trained.
Or they're just outright lying about certain things, and they're misrepresenting how much of a fossil actually is real as opposed to stuff that's been reconstructed. This is a really, really common problem, is that, you know, commercial sellers will misrepresent how much of a fossil is genuine. Good for them. That's
Look, you got to be pragmatic. As long as these things are collected, you know, ethically, meaning that they're not stolen off public land in this.
And that's also more common than you would think.
Country, or they're not imported from a country that doesn't allow the export of any fossils. Just get real with it. I mean, just get used to it. I mean, this is something that's going to happen.
If you're feeling a bit cheated, try blaming the dinosaurs.
Thank you, Squan, for the 100 bits. I appreciate that. Thank you for your support. That means a lot. Appreciate you. There you go, Spartan. I know, right? Yeah. This still hasn't sold as far as I'm aware. Yeah. Anywho, a few things that they failed to mention in this video that are like really essential pieces of info for understanding this whole issue is that in the US, fossils that are found on private land belong to the private landowner. On public land, they need to go into a museum. They need to be in a public repository. The US is one of the, I think, few nations of its kind in the world where this is the case, where things found on private land belong to the private landowner regardless of scientific importance. And most places around the world, Canada is maybe a good example. To the north of the US, in Canada, vertebrate fossils belong to the Canadian people. I think there might be exceptions where it's like prior to 1970 or something, before the laws were in place. You know, if the specimen was collected before then it could still be privately owned. But any fossils, especially dinosaur fossils that are found nowadays, belong to the people of Canada. They belong in a museum. They are there for the good of the people of the country and for science at large. In a lot of countries like that, you've got good protections for scientifically important specimens. We do not have that in the US. The almighty dollar is what rules things. So yeah, on private land, Fossils can be sold to a private buyer, they can be held privately. Regardless, it could be the most scientifically important fossil specimen ever found. If it's on private land, it's 100% legal for that landowner to keep it for themselves, to sell it, to crush it up into powder and drink it like tea or whatever. Whatever they want to do with it, they can do it. It's their property, you know? Private property rights are held in the highest esteem, you know? Highest esteem, what am I saying? I'm very articulate right now. It's private property rights uber alles in the US, you know? Which is a problem. There's another guy named Harry. Thank you for the follow. Welcome to Paleontologizing. Yeah. Yeah. Anywho.
Five.
So let's finish off with this right here. Again, the reason why we're talking about this today is because this just happened over the weekend. I think it was on, was it yesterday or the day before? This Stegosaurus specimen was unveiled to the public at the American Museum of Natural History, not because it's being held in the public trust, not because it's part of this museum now. The museum basically, I think, agreed to display it on behalf of the wealthy individual who purchased it for $44 million. It cannot be scientifically studied or published on. It's essentially a very expensive vase of flowers that they can show off, but it has no scientific importance at the moment, you know?
5, 4, 3, 2, 1. We are thrilled to unveil the magnificent Stegosaurus specimen Apex.
And Arco says, can you find any information from fossil fuels? No, because fossil fuels are the organic remains of once living things, but they've been compressed and kind of metamorphosed to the point where I don't think there's no taxonomic information about those critters anymore. You can't really wring science from those. It's just, you know, it's carbon-rich goop, you know? Is going to be any narration in this, or is it just footage? Anyway, it is a beautiful specimen. I think the majority of it is real fossil bone. The ribs don't look real, and this is a thing in a lot of commercial specimens. Is oftentimes like a commercial outfit will just dig straight through the ribs because you're like, well, who cares? Ribs take a long time to excavate, and they're really fiddly. It's like, you know, just dig straight through them, and you know, you can just fudge it later. You know, just make replica ribs. Nobody will know the difference. Doesn't matter. But that's definitely a thing. The ribs may not have been there in this case, but I kind of doubt that. The skull is... it looks like a cast, but I'm not totally sure. Yeah, the unguals look like casts too, the claws.
Probably one of the biggest fossils, like the biggest dinosaur fossils I've ever seen. It's really fascinating and it's really amazing that 80% of that is real fossils. And it's like the
Sharp
fake
kid.
ones, you can't even actually tell that they're fake. I really like it because it's like really cool and it's really big. And it's amazing that it spent 10,000 years in the ground.
10,000 years. Shoot, 150 million is more like it. Maybe 145 million. But yeah.
Waiting
Yeah.
for somebody to scoop it up.
Somebody check that kid's script. There you go, Squiggles, yeah. Yeah. Anyway, it's cool that it's really cool that people are so excited about this dinosaur. I just wish it were under better circumstances. If this were being donated to the museum, I'd be singing a very different tune, you know? And I think there would be a lot more goodwill toward the person who purchased it for $44 million. You know, the reason that I think that Sue, the T-Rex, is celebrated at all today is that that specimen was purchased for the Field Museum. Basically, it was a joint venture between McDonald's and Walt Disney Corporation. They pitched in and bought that specimen for the Field Museum, as I understand it. I know they were both involved. I think basically almost all of the money was from them. The person who owns this, the person who purchased it, they've got a golden opportunity here where they could potentially donate this to a museum, and it could benefit science, it could benefit the world at large. But so far, it doesn't look like that's going to happen. You know? Yeah. Interesting what's going on with the plate right there. That almost looks like a pathology.
I just thought, like, oh my gosh, like, this is crazy. What did you think? Awesome.
Squirrel says it'd be huge PR for the person. Long-term heavy reputation improvement and positive connections to people who would do business with them. But wealthy people rarely think long-term. That's often the case. Yeah. Ms. Event says donate it for Christmas, and it would be generate a lot of goodwill. I agree. Yeah. Yeah.
People are really excited about this fossil because Stegosaurus is an iconic dinosaur. It was discovered 150 years ago. And it's really captured people's imaginations because of its distinctive appearance. It's also central to early discoveries of dinosaurs, so to the history of paleontology. And honestly, everyone has their own favorite dinosaur, but Stegosaurus is up there in the top 5. So it's hard not to get excited about a really complete, large individual of this.
It's funny how measured he is in his excitement. This is Benson, right? This is, I think, Roger Benson. Yeah, you know, Stegosaurus is, you know, it's top 5 dinosaurs, I guess.
And honestly, dinosaur, but Stegosaurus is up there in the top 5. So it's hard not to get excited about a really complete, large individual of this animal.
I don't know, that's just very, very measured in his enthusiasm there. And I don't think it's just a British thing. I think he may have had a rough morning here too, where it's just like, oh boy, here comes the circus, you know? Yeah. E to the 2i Pi, how are you doing? Hello, hello, welcome back. Yeah. Going Cal, yeah.
Stegosaurus is a big herbivorous dinosaur that walks on all 4s, so it's a quadruped. The head is small, it had to eat a lot, and its strategy for eating food was to get as much food into the gut as possible, so it didn't chew its food very much. So it's different to mammals like us or like an elephant. Stegosaurus wasn't like, although it was a herbivore, Stegosaurus wasn't...
What's this angle they have, too? Like, they should put him in front of the head so you can see that... Maybe they
like a cow or a sheep. It's a herbivore that could look after itself. It has these wicked spikes on its tail. It has plates along its back. They're most likely not for defense, but instead for display, like the brightly colored feathers of some birds or the frills and crests of some lizards. So, for example, to attract mates or to establish dominance with other individuals of Stegosaurus. So it's a big herbivore the size of a smallish elephant that could really look after itself and had a personality.
It had a personality. Yeah. Oh, I feel bad for Roger Benson. Do the plates keep growing, SV Harkin? No, I think they're done growing. This animal died about 140 million years ago, at least. I'm kidding. Did they grow over the course of the animal's life? I think they probably reached like a maximum size and stopped growing, I would guess.
I'm going to take a sample of one of the bones of Stegosaurus because as the animal grows, its bone grows, and that leaves evidence preserved in the bone similar to tree rings that tell us about years
Lines of
growth
arrested
in the
growth.
animal.
We were talking about this earlier
And
in today's stream.
Stegosaurus, because it's a large old individual, it's going to tell us about the last part of the life history of Stegosaurus. And if we put...
But how do you plan on publishing that if it's not... if it's privately owned? If it's private property, you can't publish on it.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet.
Nell?
Or the kind you dream of in a bad nightmare.
Thank you for the 30 months of
30
support.
months of dinosaurs with Danny, very well spent.
I appreciate that, Nell. Thank you, thank you. Thanks for keeping me here on the air, Nell. Really appreciate it. Hope you're having a good day. Oh, this might be a situation like with the Big John Triceratops specimen that was auctioned off in Paris. That was controversial, but they did take a section out of one of the bones, do a histo sample, and then I think they took the histo sample and they reposited that in a museum. And they're like, oh, well, look, now it's in a public repository and we can publish on it. They might be doing the same thing here. That's kind of cheating, says Squiggles, and I agree. I mean, I suppose it's better than nothing, but I don't know. If I were the editor of a journal, I'd be like, you can't do that. Are you kidding? You're trying to be sneaky about this sort of thing? I don't know. We'll see. We'll see. The record of the histo is available for other scientists to check their work, but, well, that's the thing, is that you can't sample another part of the skeleton to kind of cross-check, you know? Which is a common method in histology, is you want to be able to sample multiple parts of the skeleton if you can. So not replicable, exactly, Salamander, yeah. Yeah. So I don't know. And Reiko says, it doesn't surprise me what editors let through sometimes. You know, they're just as human as the rest of us. Yeah. Sometimes much more human. In a bad way. I don't know where I was going with that. I'm getting tired. I've been streaming for 5.25 hours now at this point. So we're going to wrap things up. I'll give you a link to this video right here. And again, let me emphasize tomorrow's stream is going to be a really exciting one. I've got a very, very special announcement for tomorrow that is actually... there have been multiple things that I've wanted to talk about during today's stream with this whole topic of museums and making fossils available for public enjoyment and for scientific study and, you know... What we do for the public domain of science. That's a phrase you're going to be hearing tomorrow. Oh man, I've got something really excited. I've something that I'm really excited about. I can't wait to share with you when I finally got permission to share it. Big announcement tomorrow. I can't wait. So yeah, for right now, let's wrap this thing up here, and we'll find somebody to raid into. Who else is here on Twitch right now? And big thanks to everybody who's going to show up in our credits. Thank you, everybody, for making this an excellent stream. I really appreciate new followers, financial supporters like subscribers and gifters and cheerers, raiders. Thank you for coming in here, helping get these numbers up and help us rise in the charts a little bit. Continue this mission of science outreach and education. Who else have we got on right now who's perhaps doing some science outreach and education? Science Streams is on right now. Let's go see what's going on with Balint and Lita. Fellow scientists, molecular and systems biologists. Oh, and Balint is talking about ancestral spiders at the moment. Fossil spiders, it looks like. Very, very cool. Might be the perfect time to raid in. Again, thank you, everybody. Moderators, thank you for your hard work, too. I appreciate you more than you know. Viewers and lurkers and chatters and everybody. Thank you for your enthusiasm, for your questions, for your viewership, your attention, your positive attitudes, and your excitement about learning, you know? Appreciate you very, very much. Well, without further ado, we're going to continue learning here with Science Streams. See you there, everybody. And make sure to tune in tomorrow for our very special announcement. Oh, man, I can't wait. Oh, I can't wait. I'll see you then. Take care, everybody.